Hello. It is time. Alright. I think I would like to do more research on character controllers. So far this is the only thing different from what is it? It's funny, stop using rigid body. Only thing I've seen is like the virtual thing where you have your capsule and you do a ray cast down, and that can step up or step down. Ideally my ray cast would actually be oriented in the direction I'm facing. So if I'm facing left, I project forward left, and then I left, right, my left. Project forward, down, and see if I can step up or down, if the height difference is suitable. So I'm gonna watch some stuff. I'm just gonna look around. Great start to video, by the way. Actually great.
The solution is to use the character controller, but you want to have your character actually interact with Unity physics? In that case, you can simply make it so that for every contact your character controller makes with a rigid body, apply a force at the contact point in the direction of the surface normal. Hold on though, you might want more than just physics interaction. What if you want your character to be affected by physics too? So in this video, we'll go in depth on how you should be exactly making your player controller, what exactly you should be careful of, and which approach you should ultimately choose in the end. When creating a...
Okay, so here's a problem with physics. I have to like physically place my character inside of a physics object and then apply a force to that physics object with the expectation that it should push it away. What if that object is pushed up against a wall? It doesn't work.
Rigid body
That falls
controller,
apart
you've probably seen tutorials where people directly set the velocity of the rigid body. I have to tell you, this is not entirely the right way of using rigid body and something you should pretty much avoid. Setting velocity every physics frame explicitly is not recommended in Unity's documentation. Here's why. First, let's understand what a rigid body actually is. A rigid body controls objects through a physics simulation, which means that it is trying to simulate how physics works in real life. Physics simulation in Unity runs a fixed rate, which is by the way why everyone tells you to put your physics code in fixed update to sync with the physics engine. And when we force and manually set velocity every physics frame on a rigid body, we're essentially breaking the laws of physics. What you should be doing instead is adding force to the rigid body. But this, of course, also has problems. Humans move like this, not like this.
Hell no.
The truth is, the player controllers we develop for games don't perfectly represent real-life physics, which is exactly why making a proper rigid body player controller is so challenging. In real life, we don't have a
Wait a second, he's fighting a robot with a sword.
Real-life physics, which is exactly why making a proper rigid body player controller is so challenging. In real life, we don't have a floating capsule. So how do we do this the right way? First of all, we need to use the force mode of velocity change when adding force to the rigid body. This ensures that velocity changes aren't affected by the rigid body's mass or the simulation step length. Next, we need to fix the slipperiness problem. This can be solved by applying much higher drag while the player is on the ground. I want to emphasize, only when on the ground. Why, you might ask? If you were to, for example, walk off an edge, you'll notice your character will glide and float unnaturally. So you need a separate ground check system, which I'll explain next, to determine whether your character is in air or grounded. If a character is in the air, you'll want to set the drag much lower. How do you handle ground checking with rigid bodies? You might say just a simple raycast, but to this, I'd like to say this isn't going to give you accurate results. If your character is on an edge, it will falsely report that the player is in the air, which definitely isn't what we want. As alternatives, we could use a sphere cast, which shoots out a sphere instead of a single ray, or use on collision enter callback. However, with both approaches, you also need to verify that the collided surface is actually ground. What I mean by this is that if you hit a wall, it might register as ground too. So if you walk off while colliding with a wall, your character controller might hit an edge case and still think you're grounded. To fix this, you can either—
Hey, that's cool. That's exactly the problem I'm having.
Manually assign all real ground objects to a separate ground physics layer, or check the slope angle. The slope angle is the angle
Different physics layer for the floor. So that way my capsule cannot collide with walls. But then I can't just draw a box. I can't just draw a box. I can't have an object that's both a floor and a ground. I think that solution is still just to have a smaller thing. So if I have a capsule that's this large, I have a sphere that's fully contained within that capsule that I can be pretty confident won't report wall collisions. I guess what I could also do is I could say if it's not
between the player's down vector and the ground surface's normal vector. If this angle doesn't exceed a certain threshold, then you register it as ground. As a different way to fix this problem, you could also theoretically make the sphere cast slightly smaller than the collider so it won't register walls, but this has caused other edge case problems for me. We're not done with the problems yet. We also have slope problems. Since we have a rigid body, which is a physics object, on the slope, it's natural that our physics object will slide down. To prevent this, we can add a counterforce upward that counteracts gravity when you're on a slope. Sure, now let's try moving on a slope. You'll notice your rigid body player controller moves slower when going uphill and faster going downhill. You need to ensure the force you're applying isn't based on the player's rotation, but is parallel to the ground surface. You can get this vector by taking the ground's normal and finding the perpendicular.
What was his actual solution? Was it really just the physics layer?
Edge case register to verify that the collided surface is actually ground. What I mean by this is that if you hit a wall, it might register as ground too. So if you walk off while colliding with a wall, your character controller might hit an edge case and still think you're grounded. To fix this, you can either manually assign all real ground objects to a separate ground physics layer, or check the slope angle. The slope angle is the angle between the player's down vector and the ground surface's normal vector. If this angle doesn't exceed a certain threshold, then you register it as ground. As a different way to fix this problem, you could also theoretically make the sphere cast slightly smaller.
Maybe what I can say is if the angle is sharp enough, apply a small push force away from the edge. But not too sharp. I don't know.
Smaller than the collider, so
he says slope angle, but then it's like
won't register walls, but this has caused other edge case problems for me. We're not done with the problems yet. We also have slope problems. Since we have a rigid body, which is a physics object, on the slope, it's natural that our physics object will slide down. To prevent this, we can add a counterforce upward that counteracts gravity when you're on a slope. Sure, now let's try moving on a slope. You'll notice your rigid body player controller moves slower when going uphill and faster going downhill. You need to ensure the force you're applying isn't based on the player's rotation, but is parallel to the ground surface. You can get this vector by taking the ground's normal and finding the perpendicular vector to that normal. And then when going downhill, you also need to ensure that the force you're applying matches the force when going uphill. What I mean by this is that you have to account for the gravitational force that's constantly applied to your character. Since our movement on a slope is perpendicular to the surface, we can simply add an upward force matching the gravitational force so that it would counteract gravity here as well. Alright, do we now have the perfect rigid body controller? Unfortunately, not quite. As soon as we start walking upstairs, you'll notice the next problem. It simply won't work. The issue is that humans have legs that can bend to climb stairs, but we're working with one solid physics object that needs to somehow get up or down those stairs. There are several ways to solve this. The easiest is replacing the stair collider with a slope collider instead. So while it visually looks like stairs, your player controller actually interacts with just a slope collider. You can then add additional camera bobbing effects to make the stair climbing feel more realistic. But sometimes you want real stairs with real colliders. It also makes the environment designer's job easier. There are also a couple solutions for this as well. Here's one I like to use. Teleport the player up to match the stair height if they collide with one. Since you're moving forward, the player controller has forward force applied constantly. So now if you just teleport the player up, it's like continuously walking forward, but your character will teleport up the stairs. For this, it's crucial that you use rigidbody.move position to teleport your player because this creates smooth transitions between update frames. You'll also need interpolation enabled in the rigid body settings, which you should have anyway if you're making a first-person controller. What about going down? Same principle. You want to teleport the player's position to the stair below. Otherwise, you will just glide through the stairs. Okay, now we have at least a functional player controller for most scenarios. I say most because you never know what physics problems you'll encounter later, which brings us to a different solution, not using the physics engine at all. Unity's character controller. Since the character controller doesn't use Unity's physics engine, we update it in the update method. Many people think that every moving code needs to go in fixed update, but that's not the case. The benefit of using the character controller is that most problems we had with rigid bodies simply don't exist. We don't even need to implement separate ground checking. There's one already built into the character controller. Slopes works out of the box, no slipping, equal velocity in both directions. Stairs, also built in and adjustable with the step offset property. For interacting with physics objects in the scene, you can do what I mentioned in the intro, just apply forces manually for each rigid body collision. So the conclusion is that with all these features built in, unless you really need physics simulation, I'd definitely recommend sticking with character controller for most cases. That is, unless you're making a game where your player needs to be pushed back by wind or something. Even for things like ragdoll effects on death, you could take a hybrid approach where you enable rigid body and disable character controller when the player dies, and then obviously switch back when they respawn. That's about it. I don't usually make tutorials.
Man, I didn't learn anything.
If you've ever tried searching the internet for the best way to make a character controller from scratch, you've likely come across, as I have many times now,
He touched on every single problem that I have. In fact, even the problems where collision with a wall breaks. In my case, maybe it's a bit different. Maybe as long as I am grounded, I can just counteract gravity. Possibly. And then I would just actually skip the spring.
People
I don't know.
dismissing the problem outright. Just use a dynamic rigid body. Just float your collider off the ground. Just use the built-in controller. Now, don't get me wrong, these are all perfectly valid solutions in many cases, especially if you're trying to throw something together really quickly, such as during a game jam. But they are not the solution, counter to what many annoying YouTubers and Stack Overflow repliers seem to believe. There are some good existing solutions out there, on YouTube or the Unity Asset Store, even many that are free. Now, personally, I think a lot of these are far too complicated for their own good, but it's hard to deny their effectiveness at colliding with even very complex geometry without clipping through walls, falling through floors, jittering, or really bugging out in any way. The way they're able to accomplish this is using a surprisingly simple algorithm called collide and slide. Here we have our character, represented by a capsule, as is common across the vast majority of modern 3D games. The collide and slide algorithm actually works with any shaped collider as long as it's supported by your game engine, so for the sake of simplicity, let's instead represent our character using a sphere, and we'll move the origin to the center as well. Let's say our character is moving in a straight line with some arbitrary velocity. We'll forget about stuff like gravity for now. Eventually, our character encounters an obstacle. Because our character is kinematic and not being driven by the physics system, by default it'll just pass right through. So what should we do instead? Let's briefly touch on collision detection. If you're using a pre-existing engine, collision detection is fairly straightforward. In Unity, we can make use of the built-in shape casting functions, which take a shape and sweep it along a direction to detect any intersections. In this case, using sphere cast obviously makes the most sense. But collision detection isn't really what we're concerned with. Like I said, that's pretty much taken care of for us. What we actually care about is collision response. Let's go back to this simple example. What should we do when we encounter an obstacle in our path? Well, the naive approach, I guess you could call it, would be to move as close to the surface as possible without overlapping, and then stop. And in this case, that's actually what we would want. But what about this case? Or even better, this one? Here, just stopping when we collide doesn't make as much sense. And that's where the collide and slide algorithm, as defined by Casper Fauerby in his paper Improved Collision Detection and Response, comes into play. Let's break it down to the absolute basics. We start with an initial position and velocity. If a collision is detected along the velocity vector, we reduce the velocity to stop just before the collision point. This is the collision step from before. Now for the sliding. We subtract this new velocity from the original velocity to get the leftover amount we would have continued moving had there been no collision. Then, using the normal vector from the collision data we collected, we project this leftover amount onto the collision plane. In Unity, we can use the built-in project on plane function. If you're not...
There's still an issue with this. The main issue with this is that if I interact with an object that is massive, but movable, I could just say I don't have that. Static environments, no dynamic physics. I could go in the other direction where I'm pretty sure just in Halo CE, your character cannot push physics objects, but any physics object that hits you with enough force just kills you. You can still be pushed, like for, collision recovery or whatever, but, pushing the player out of a surface. But these are concessions. I don't like to make concessions. I don't want to have a character controller where I have to say, all right, never anywhere in the world can I ever have a dynamic physics object that I can push. That can push back on me, I guess. I can have small objects, like small things that if I walk into, they just fling. They don't affect the player at all. And that would still work in this case. But if I have anything large that can push me, I lose that. With a rigid body, I get that just out of the box. I literally don't have to think about it. It's just built in. And what I can do is I could really go into what is it? I could just go into Jolt and use Jolt physics character controller. I can extract that. I did that with the vehicle body, and I was really happy with the vehicle body. So maybe Jolt would be really good. This is just something that I don't want to do. I don't want to deal with, I guess. Let me really quickly look at Jolt. Really quickly. Yeah, character. I'm not really sure the organization of this. Let me look at a layer, mass, friction, gravity, degrees of freedom for movement. Impulse. Check collision. Would these be in constraints, by the way? Like a constraint character or something? Character base. Settings. It's nothing. Ground state. Whoops. Ground state? Steep ground. So does it extend character base? It does. I don't think character actually does anything. I think character is just a lot of some basic stuff. Character get body interface. Body interface. S character get body interface. What? Character get body interface. In system get body interface. System. What's the system? Cached physics system? It takes in the system. Virtual is a character base. So is character. Wait, so what's character? I'm a bit confused about how this works. Yeah, I'm really confused about how this works. So this is just an interface for character base. But it doesn't do anything. It does like almost nothing at all. So it's character base, character virtual, contact settings. This is a character base, so character's not even used. Character base test, character virtual test. This has an example for crouching and standing. Whoa. This is just the map, I think. Yeah. It takes an input, control input. It's a vector. It just takes in control input, that's it, and rotates it. View physics update. Camera pivot. Huh. Rotating. Okay, so this is just seeing the stuff. Animated character, I suppose. Assign, time, character velocity. Interesting. Character virtual. Okay, so there's base test and then there's this test. Just nothing there. The player character. Pre-physics update, post-physics update, post-simulation. Handle inputs. Interesting. We take our current velocity, 75%, and apply 25% of our desired velocity. Interesting. Sure. Okay, so if we're falling, or we have a desired velocity, we don't want to inhibit the Y motion, which this is just gravity. I would actually have this set up to be like, yeah, I don't like that part. I don't like that part. Okay. Virtual test. Prephysics update. Remember old position. If enable stick to floor step down. No, if it's not enabled. Otherwise, if it is, it's this. Okay. If we can't step up, okay, these are like rays. Or directions, really. Extended update. This value, gravity length. The direction of gravity, I guess. Gravitational force, right? Update settings. Moving. That's empty. This is just nothing. I'm pretty sure that's what this means. Temp allocator is just there because it needs to put something somewhere. But we don't care about the results of that because we don't use it. And then go through all the contacts. And do what? It's an assertion. So this doesn't actually do anything. Okay. Whatever. Calculate effective velocity. New position is character. So this moves the player. And we calculate a velocity. Handle input. What? Update settings. Character. I like Rigid Body, man. I just like Rigid Body so much. This is just so much stuff. It really is just so much.
Using Unity, don't worry. Projecting a vector along a plane is quite a common formula
just so
and should
much.
be easy to find with a quick Google search. You might have noticed that projecting our leftover velocity has lost a lot of magnitude. That is, the resulting vector is much shorter than our initial vector, meaning we won't move as far as we're supposed to. To remedy this, we'll normalize the projected vector, giving it a magnitude of 1, and then scale it by the magnitude of the original leftover vector, which ends up looking like this. And that completes the sliding step. The final piece of the puzzle is iteration. What happens, for instance, if our projected vector passes through another obstacle? Well, we just run the calculation again, but starting from our new position and with our new velocity. This is then repeated until there are no collisions, or until we reach our maximum allowed number of iterations, also called bounces. In the end, we sum up the projected vectors, and that gives us our final velocity. And that, in a nutshell, is the collide and slide algorithm. It does have a few small issues that I'll address at the end, but for now, let's look at how we might implement this in code. Since I'm using Unity, I'll be demonstrating using C#. We'll assume that we're starting with a given velocity and we want a new velocity in return. Like we covered before, the two parameters that we absolutely need are the starting position and velocity. For the sake of space, I'll be abbreviating some of the variable names. Now, you could write this function using a loop, but I find it easier to conceptualize using recursion, where each recursive step corresponds with each collision bounce. For that, we'll also need a parameter to track our current depth in order to avoid a stack overflow. Inside the function, we first need to define a base case that will end the recursion. We'll define a member variable to cap our recursion depth and return 0 if we reach that level. We'll also return the current velocity if there's no collision and we're not in the base case. Next, we'll perform our collision check. I won't go over this in a ton of detail, so if you aren't sure what's happening here, you can look for other videos or read the documentation. We'll start by defining a member variable for a skin width, basically a very small distance inside our collider that we start our collision checks from in order to avoid clipping through stuff due to floating point inaccuracy. Every frame will need to get our collider's bounding box and reduce it by our skin width. Here's the code for that. Because we're reducing our bounds by our skin width, the distance of our collision check will need the skin width added onto it. Then comes the actual collision check. If there is a hit, we want to get two vectors, the distance to the surface and the leftover velocity past the surface. Next, we'll project the leftover vector along the surface and scale it to the correct length. And finally, the recursion step. We return the reduced velocity plus the next level of recursion. And that's collide and slide. In this basic form, there are a couple issues that we need to solve before we can use it in our character controller. The most important fix is a check to make sure that our snap to surface distance is greater than the skin width. This is to ensure that we always have enough room for our collision check to work properly. Next, there's some video gamey things that don't affect the collision directly, but are things you'd expect in a 3D game character. Currently, our character slides down any slope, even at very shallow angles. In most games, we only want to slide down slopes that are steeper than some predefined value. So let's define that value and then check it in our collision step. Our code is getting a little messy, so let's move our projection math into its own function. Now, the easiest way to fix this sliding issue is to
Just
split
3 lines
our
of
initial
code.
velocity
What are you
into a
doing? Don't do
movement
that.
vector and a
Don't do
gravity vector, and then make two collision passes in our movement code.
Just write it
As
all out.
Faurbee outlines in his paper, doing this actually incurs no performance penalty and helps for additional code you might implement like climbing stairs. So let's add a flag for whether or not we're in the gravity pass, and if we are, don't slide on shallow slopes. Next, we have to talk about walls, and this part is a little hard to explain, so please bear with me. Currently, our controller maintains all of its speed when sliding along a wall, no matter what angle the collision is at. You might have noticed that in most games, however, usually what happens is that moving directly into a wall stops you in your tracks, and as you try and move more parallel to the wall, your speed increases. So let's implement that. We'll need to keep track of the initial direction the player was trying to move. Next, we'll scale the
This just means the
velocity
first
based on the
iteration
angle
you
between the
don't
surface normal and the
multiply.
initial velocity.
You don't
Using the
normalize
dot
by
product
remainder.
conveniently gives us a value between 0 and 1, which we can then invert. Importantly, we only want to scale the horizontal movement, so the y-coordinate of the two vectors is set to 0.
Also, I'm
Lastly,
not sure why gravity pass is provided here. You check gravity pass, and then you're always false after that.
can scale the projected vector by this value. And finally, I promise this is the last thing, to avoid jittering when moving along the bottom of a steep slope, we can treat the slope as a flat wall if the controller is grounded. So here we have a full implementation of the collide and slide algorithm that's actually usable in-game. I used SphereCast for the collision check to keep it consistent with the animations, but it should work for any shape, including capsules. Now, there is still one minor issue with this code that I know of, and it's this. What's happening is the collision gets stuck in an infinite loop, so we end up not moving at all. The solution to this is actually outlined in a second paper by Jeff Linehan. It involves finding a crease vector between the top and bottom surfaces and projecting along that instead of either surface. Linehan takes an iterative approach rather than recursive, but I think his solution could be adapted to work with our recursive code. I'll be sure to post a follow-up video once I figure it out. Okay, so I went back to my original code and this scenario just works now, and the only thing I changed was the min ceiling angle that I was using to check for a ceiling collision for gravity stuff. So I guess the code works? I don't know. Let me know in the comments. For now, all that's left to do is apply our function to our controller's velocity. I hope you found this video helpful and it leads to more robust collision in your games. Thanks for watching.
Oh, man. No stairs. No stairs. No stairs.
Start off by creating a new Unity project. Once you've
I'm
done
just
that,
running into
right-click
this.
in the hierarchy panel.
Oh, not watching this one. Not watching this one.
So if you're creating a first-person
I don't see stairs. All right, character controller, stairs. Right? Don't tell me to make them ramps. Rigid body, set up stairs.
Climbing. To fall properly, you need to get high. This instructional video was
What is this? Why is it?
prepared for everyone who does not feel high enough and is ready to do something about their situation. Climbing is as easy as doing.
Dude, why do I feel like I'm hearing... Did I just skip that?
Why they
I'm
don't
just gonna
have
skip
to.
that.
There are a few key
I'm just
things
gonna skip
game
that.
developers can do to make the stairs easier to navigate and look much smoother, but a lot of them don't do it. I'm not saying that I've solved stairs, but I think I'm pretty darn close. So before we dive into that, let's first agree on what stairs are. They usually look something like this on screen, a set of steps at about a 90-degree or so angle to the ground, and if it's less than 90 degrees, you
90
expect the player to
degree?
slide up it like a slope. If the player walks into an object at a 90-degree angle, they'd probably want to stop because they're walking into a wall or something.
I
This
guess they
makes
just
sense.
mean
However,
the
what if this wall is low to the ground?
step
Well,
case?
that's not a wall. It's a step. When the player encounters a step like this, we don't expect him to stop like he does when he walks into a wall. We expect the player to go up the step smoothly. It should look natural and not jittery. It should be fast as well. I mean, even though the surface area of the step is more than that of a ramp, walking up a set of stairs shouldn't be slower than walking up a ramp. Most built-in character controllers have support for stairs, and this is important because this kind of a step
Most.
isn't only found in a staircase. It
Godot,
shows up more places
unfortunately.
than you might think at first. I've dubbed this the stair problem, as it's led to so many issues in developing my OpenKCC project. So you might be thinking this already, but what if we just hide the stair problem behind a ramp? I mean, isn't this like a lot of old video games did? Make the staircase into a ramp for the character controllers so they can slide up it like a slope, and then you can just round the edges of the character controllers.
Thinking about this now, I don't know. Oh no, they do. Wait, do they? I'm actually not sure if Halo ever has a stair. I think it's always a ramp. It's always a ramp. But in later games, they do have stairs. But I think they're ramp colliders as well. I think those are ramp colliders. If we were to drop a weapon or something on them, or throw a grenade at them, they bounce smoothly. Like it's a ramp, not like it's a staircase.
That they can bounce off any of those rough surfaces. And there, the character interacts realistically with most terrain, and you don't got to worry about it. Lots of games can get away with doing this. I mean, even big franchises like Pokemon, Overwatch, and Skyrim use these kinds of tricks for making their 3D worlds easier to explore.
Yeah.
If you add some inverse kinematics for the player feet to have them lock onto the ground, with a little animating magic, the player will hardly notice the hiding of the stair problem. Inverse kinematics is an animation technique to set the target position of a rigged avatar and compute how the joints and body positions would have to align to reach there. Think like if you stretch your hand out to grab something, your elbow bends in a specific way to reach it, and won't move like a brick or detach from your shoulder to reach it. Assuming the IK doesn't totally glitch out, it should be fine. If you put enough of these tricks together, you can mostly ignore the problem of stairs from many video game scenarios. Some games even have their colliders float above the ground to make use of smoke and mirrors to kind of move the character visually down to the ground and just avoid the stair problem entirely. So if hiding the stair problem works well enough, let's try that. We just need to replace the stairs with a ramp. Easy. It'll take some work, but it's just a one-time cost. Now, wait a second. It looks like you forgot something. That little curb between the road and the sidewalk? Yeah, that's also a step. You don't want the player getting stuck whenever they try to walk into that, so let's put a ramp there. Oh look, on the side of that ramp for the staircase, the front corner of it's a little bit jagged. The player could get stuck on that unwell. Let's round that corner out so the players don't get stuck. And now we have a million little things to correct about our map, or just accept that some stairs can't be hidden easily. Don't even get me started on curved staircases.
So Counter-Strike actually uses ramps. It might have changed in CS2, but I remember them specifically doing a blog post about fixing the stairs on Dust 2 on Dust 2. Yep. In tunnels. Where they specifically said, here was our old ramp mesh collider we made. Here's a new ramp mesh collider we made for these curved staircases. At least in that case, it makes sense because you actually want people to be able to bounce grenades off of the steps and it move predictably, as if it was a ramp, even though it's not a ramp at all. They do it, but they have. I mean,
Some
it's
games
just
do
work.
take this path of beautifully crafting a world like Breath of the Wild and make sure that stairs are all interactive and responsive. Sometimes there are design flaws that the character can get stuck in, but otherwise it works pretty well. And if your character can't handle walking over some broken steps or jagged terrain, just get rid of them or don't let them get too close to it. But now you've just shifted the work of dealing with stairs from the character movement programmer to the level designer. You can't really hide the stair problem, you just put that work somewhere else. Now, while some games may be able to get away with this problem on the level design, my OpenKCC library is for any game developer to use, and I can't just shift that work to anyone that wants to use it. I mean, I don't want to include a disclaimer, this doesn't work with stairs unless you do X, Y, Z, and I would rather just kind of solve the stair problem. Walking down steps is easier than walking up steps, so let's look into that first. When the player walks forward and they hit a staircase, they should keep their feet glued to the ground of each step. If we were to just move the player forward and not respect the steps at all, the player would just start to move like a little bouncy ball, going off the edge and then hitting the ground, and off the edge and bouncing on top of the stairs. Even if we replace it with a ramp, this would still happen. So to get around this problem, for both steps and ramps, we can simply snap the player down whenever they move. After the player moves, we check if the player is close to the ground, then snap them down. That way we avoid looking like a bouncy ball and leaving the ground whenever we go down a slope. To snap the player down, we just need to cast the collider in a downward direction, similar to how we check if the player is grounded in my previous video about player movement. Then, when they hit the ground, we can check if it's within some small threshold, and then we can just teleport the player down that distance. However, we can't apply this all the time. Think of like walking off a cliff. You don't want the player to instantly snap down to the base, we want them to fall normally. Additionally, if the player is falling towards the ground, we don't want to teleport them the last few inches away from the ground and snap them down, because, that would just look weird. We also need to turn off snapping if we're trying to jump. I mean, if we leave snapping turned on and we keep on jumping, we just never leave the ground, and that would just be embarrassing. When snapping is added correctly, we can walk down steps well, and we're halfway to solving the stair problem. Woot! Oh, yeah, right, we also need to go up the steps, too. Well, we have that rounded collider idea from earlier, let's see how well that works. If we try and use this rounded collider, it's not going to look very smooth. You're going to kind of switch between bouncing up a step and then walking forward, and you're not going to have a very constant velocity as you'll be switching between these two states very quickly. It's kind of a mess and just doesn't look right. And also, what about overhangs? I mean, this is another edge case to look at, just like the street curb. If we hit an overhang, we won't be able to just slide up it because it's a really jagged edge. This overhang scenario is like if the bottom of the step is behind the top of the step, so it's kind of jutting out forward. And there are also even more edge cases to consider that I didn't mention besides just overhangs. I mean, we could do the same thing as before and put this work on the level designer and just hide the problem, but that's just shifting work. And while this might work for some games, I want to at least have a partially working solution to this half of going up the stairs as well. So earlier we discussed about snapping down steps. What if we just do the inverse and snap up steps? So like whenever you hit a step, have the player teleport up and then just go forward normally. This solves the problem of bouncing off the step and moving at an inconsistent velocity. We just need a way to figure out how to teleport the player to the top of each step. We can use the collision data to get the height of the step, which even works for overhangs as well. Nice. Teleporting the player up to that height and then check if we walk forward. The reason we need to check if we can walk forward some minimum distance is because if we don't and just let the player teleport up any solid surface, they just walk straight up walls and cliffs. We also need to set some limit to the maximum step up height to stop the player from climbing up low walls. So from this we have two variables, max snap up height and min snap distance. Snap height is the snap up height, the maximum step height that we can climb up, and the snap distance is the minimum step depth that we would expect to be walking on. I mean, you wouldn't be able to walk on a staircase that steps are just like a couple inches thick. You need at least at some length to put your toes on there, otherwise you just slide right off. We can use the same collision algorithm as we used earlier for checking when the player snaps down, but instead going forward to check if we hit anything. If there's solid ground to stand on in front of the player, then we can let them teleport up and move forward. If not, we just leave them back at the base because they're probably walking into a wall. We have to add a final little check to snap the player down after we teleport them up. This is because otherwise they teleport up and could be floating on top of the step and then just fall down. I mean, that would just look kind of silly. So this is done just like snapping down before and doesn't cost much extra compute time. So does snapping up and down solve the stair problem? Well, as a lawyer might say, it depends. It works in most cases, including some of the edge cases we discussed earlier. It doesn't snap over walls, allows for configuration of what's considered a step, and works on the sides of ramps and overhangs. However, it does involve making more collision checks whenever the player bounces into something, so it's not free. However, adding an extra collision check is so simple that it's not really a big issue. Whether you do 3 or 4 ray casts on a player movement doesn't make that big of an impact. Sometimes, if collision physics is off and the player is in some kind of complex situation, it won't work every time, but we can hide those mistakes of a rounded collider and by using the neat tricks we discussed earlier, like inverse kinematics for the player feet. So overall, I'd say snapping mostly solves the stair problem. So, now that you know the solution to the stair problem, you shouldn't accept kind of bad stair implementations from your favorite video games. Developers can add extra polish like this if they're given enough time and resources. If your character gets stuck flipping onto the edge of some small box or ledge in the game, you know it's because they never addressed the stair problem. Although, I really wouldn't be too hard on these game developers. They're a lot of times under time crunch pressure and need to satisfy more stakeholders than just making a character look nice like I can do with my library. With this knowledge, you can look at some of the foot inverse kinematic magics in games that you play. You might be surprised about how many games use this trick to hide.
Hmm. I'm looking more at rigid body. Still not learning anything. It's just telling me to do the things that I'd tried before. Interesting. Music. Wait, hang on. Were there stairs in the background? Stairs. 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 Alright, that's gotta be mute. I'll just play mine. Anti-collision, okay. This, wait, please go to the stairs. Please go to the stairs. Please go to the stairs. Hang on a second. So, if this is asset store, real link? Oh no. Oh no. 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 I'm assuming rigid body interaction just means yeah, I'm assuming it just means it teleports a rigid body to your location and uses velocity calculations to keep it in your position. I'm assuming that's what this means. Go to the stairs. Also, is this guy really on controller? Oh my gosh. Okay, so it's definitely not spring. It jumps off the top, though. Which, I mean, that's actually something that you see in Halo. That happens in Halo. When you're going up a slope, it doesn't keep on the ground. You actually launch over the top of ramps. But when you're going down, you go down the ramps. Oh, okay, so he actually just uses normal... He's just using the curve of the sphere to walk up stairs. That's really lame. So you have to make ramps. Dang. Yeah, that one's not very good. I do really like... Okay, so I'll say this. I still really like the rigid body spring thing. I do still like that. I have an edge case where you can phase into the floor if the spring believes that its closest collision point, its deepest collision point is a wall and not the floor beneath you. All right. I think making let me try this. Let me start by making it a sphere, and then I'm just going to make it smaller than the player. I will just say we'll use a sphere, and it's going to be smaller than the player. So I make it 0.3. I think I can actually disable the margin entirely. So it's just, it will very precisely measure contact points. I think this is a more or less like a very small value. I can't type in a value that small because it's... Oh, I can type it there. All right. Well, I'll just leave it at 0 because I'm sure it uses a very small epsilon. Or I can just do some calculations to measure a more precise difference. So I'll start with that. And then on the actual rigid body, I will use... Why does this one not actually have... I guess it always just interacts via the collision shapes. So I just set up the collision shape, I guess. I'll give it a 0 margin there. Okay, so there's a difference of 2 centimeters. I'm already in the ground. Okay, so then what I should do is make this sphere cast. Starting at 0. Looks actually... Okay, let me move it out here, I think. And 0.65. So let's go up to 2 centimeters. And then have it cast down like 3.5. There. Okay. So it starts here and it casts down. Alright, there's a bit of a intersection there. But I might be okay with that. I should probably go and get the camera set up to it like a third person thing. So I was able to run into this, which was interesting, and climb up it. If I'm looking at this, oh. Okay, let me make it so that... There we go. So now this is technically a 0.6 step. A 0.6 step. This would be a 0.65 step, which is what it was before. A very large step that somehow I can climb up sometimes. You know, maybe I'm okay with that. Okay, so here's a 0.6 step. Can't really climb these. A 0.55 step. Pretty smooth. Those slow velocities, you know, you kind of struggle to get up it. Okay. 0.5 step. Pretty easy. It seems to get up this. And I'm totally okay with it taking effort as well. You know, like you walk into this and it's a bit slower to move up. Totally fine with that. .85 step. Or a 0.45 step. Basically effortless. You can walk straight up that. And 4 step. I don't mind that it's a bit launch. Yeah, I don't mind that. I mean, this is... like, this is working, right? Like, this is pretty good. I can't say this is not a viable solution. I think... and also this should technically work as well, just naturally for spinning platforms, because the physics engine just handles that. I don't have to do math for that. This thing has mass, so anything collides with it will push it, and it will push back naturally. And I mean, I can just make it, you know, make an effort to not have steps be too extreme. If I intend the character to walk up a step, they shouldn't be too extreme of a difference. If I intend them to, like large boxes, I'll make sure that they're large enough that you shouldn't really be able to jump up them. Though you could like jump and then walk into something to force yourself over it, for sure. Let me go revisit this video. There was one here that said stop using rigid body. And he goes over a lot of problems that I agree are problems with this.
Is to use the character controller,
Let me
but you
walk-
want to have your character actually interact with
watch through
Unity
this again.
physics. In that case, you can simply make it so that for
And
every
see-
contact your character controller makes with a
And see,
rigid body, apply a
Double
force
check
at
the
the contact point in the direction of the surface normal. Hold on though, you might want more than just physics interaction. What if you want your character to be affected by physics too? So in this video, we'll go in depth on how you should be exactly making your player controller, what exactly you should be careful of, and which approach you should ultimately choose in the end. When creating a rigid body controller, you've probably seen tutorials where people directly set the velocity of the rigid physics code.
I understand this. It's just going through. Oh, here it is.
Next, to determine whether your character is in air or grounded. If a character is in the air, you'll want to set the drag much lower. How do you handle ground checking with rigid bodies? You might say just a simple raycast, but to this, I'd like to say this isn't going to give you accurate results. If your character is on an edge, it will falsely report that the player is in the air, which definitely isn't what we want. As alternatives, we could use a sphere cast, which shoots out a sphere instead of a single ray, or use on collision enter callback. However, with both approaches, you also need to verify that the collided surface is actually ground. What I mean by this is that if you hit a wall, it might register as ground too. So if you walk off while colliding with a wall, your character controller might hit an edge case and still think you're grounded. To fix this, you can either manually assign all real ground objects to a separate ground physics layer, or check the slope angle. The slope angle is the angle between the player's down vector and the ground surface's normal vector. If this angle doesn't exceed a certain threshold,
I just got an idea. So if I have the shape be the same size as the player, I do run into the issue of the player sinking into objects, especially if they are part of the same collision body. Actually, I'm not sure. I think what may be a issue with, actually, yeah, maybe that is. CSG produces its collision shapes, I think, by just copying the whole visual mesh and saying, here's your collision shape. So this piece is one shape. Ideally, what it would be is at least a plane, a surface plane is one shape, and then I have a different shape entirely, which is how you register collisions. You check motion through a shape. So this probably really was just an edge case with CSG stuff, where the method that it's producing its collision shape is a single shape. What it should be is a different cube per step. Right, okay, so this is where, okay. I'm gonna go ahead and get the camera working. I have input set up. I'm gonna go and make the camera stuff work so I can get in here and I even need to make it a third person support as well, so I can pull out and stick to the player. So I'll start with that. This should not be visible to the camera. Let me go to the camera and see if I can make it. I could do this. I could say, I was going to say no first person, but that actually doesn't work. I need eyes on the front of this capsule. I guess it should be up here. I mean, I guess I can just make this invisible to the camera. Alright, sure, I'll say this. Say third person only for layer 2 and toggle that, which will mean these are toggled off. I can just make them exist only on layer 2. And then this camera cannot perceive them. That's fine. There's also ways to make it just so that when things are close enough, or certain things are close enough to the camera, they are just straight up not drawn. I'll leave that up. Doppler tracking. Oh, this should be... What? Yeah. Okay. Also, I don't think I need 4,000 meters. I think I'm gonna stick to pretty small maps. Okay, I'll leave that. Current. And now for input stuff. So I'm gonna go ahead and make a new, let me extend character, player, I mean, that all looks exactly what I want there. Have a scene, okay. So character controller, I'm just gonna take those out. Integrate forces, that just goes away. So integrate forces, I think also will take in motion stuff. So this is where I will apply forces for motion, for like acceleration. I'm intrigued a little bit by the interpolation of current velocity to desired velocity. But I think it probably just works best if I have an acceleration. And my other character controller also had friction, which would apply greater opposite to your direction of motion. So if I'm walking forward and I press the back button, my desired direction is completely opposite to that, so I apply like extreme. I apply an extreme friction force in that case to get them to reverse direction really fast. There's also a little bit of stuff for if you're going forward and strafing side to side. I maintain a lot of that velocity, so if I'm going this way and I try to go that way, I can redirect. I mean, at least in that case, it'd be like 90 degrees, right? So that's already a pretty dramatic difference. Okay, but I'll just do this. I have is on floor, spring total lambda, which I'm not even using anymore, so I get rid of that. I will have a... Well, I just have a... Yeah, I'll just straight up track a desired velocity. And I update this from player. So... And this is process. So I constantly update my desired velocity based on my inputs, so as soon as physics tech runs... Well, I guess I only really need to pull for input once I get to physics anyway. Let me do this. I think what I would like to have instead is... I will just make my own handle input thing. And the idea behind this is that I implement it in controllers, which is just saying, hey, I'm ready for you to tell me where you want to go. So that's the idea. So I would just have a handle input call at the top. Yeah, so characters will be extending the character controller. But I provide input through APIs. So yeah, handle input will do things like saying, like calling set desired velocity, set jump, set crouch, stuff like that. Okay. Okay. So I'll process for camera stuff, so I'll just say, and no input. So player will have these actions. Okay, so here I just take an action move, and that just becomes my desired velocity. Yeah, quite literally. And it would also be multiplied by the forward vector, or the forward. It's oriented based on my transform basis, which I think I need to go look. I think I am just multiplying it by the transform basis. I think that's what I do. Okay, well, I have to go open up. Whoa. Go open up a zombie game and go check that. Character, player. Should just be in like physics or something. Axis movement direction, basis times that over move length. So I'm giving it a direction. Here I actually want a desired velocity completely. Which I am normalizing it, so alright, I guess I do that. So yeah, it's just basis times value axis 3D. Which I guess it should actually be global basis, really. In case player is part of a world that spins or it's childed to something. So I'll say global basis. And this one should be normalized, so I think I can just call normalize on this, and that's fine to run. I guess I can do 1e -4, so I can ensure that's at least something. Then I do that. Otherwise, I say my desired velocity is 0. Oh. Right, and then I didn't actually configure this, so I go to here, inspect, quick load, look. I don't even have move set up yet, which is funny. Okay. Input camera. I guess I say this is a context where you can move a character around and possibly turn the character. I'll just call it first person. I'll call it FP. This is just meant to be movement. And then I would have to enable the context, of course. So this should be an axis 3D. Call it move. Can make it remappable. So this is W S A D. Should probably be WASD. WASD. Then I check my notes. Forward, negate swizzle ZYX. ZYX. I think it's just that Z is first, but whatever. Or X is on the Z, I mean to say. Because a Boolean just applies like a 1 to the first term. Negate for right. Is there a normalize? I can normalize the inputs. It doesn't really do anything though, because it actually adds them all together. Where am I going? Swizzle, and then left is nothing. Okay. And then what I would have to do is I would have to enable these. So for now, I'll just say if a player is placed in the world, we will just enable these contexts. Technically, input context should be controlled by someone else. So I suppose what I should do is probably have a script out here that probably just extends node, and I can just call this context manager or something like that, so that, and it becomes a global thing that can manage context. So I can say, the player can say, all right, let's flip to this input context. Pressing a button can open a menu which says, all right, let's flip to this input context, disable these ones, things like that. I could even do it stack based, actually. So if a menu opens up, it can say, let's enable this context and let's have it be an override. So disable everything below me and enable me. So if I get into a vehicle, it might even say, I guess that would just be player. The player would say, let's turn off weapon input control and movement input control, and let's turn on vehicle input control. I definitely would like a central location to just say, here's all the context I have, like register a context or something, and then I can enable that context. Maybe that doesn't make much sense. Maybe I should just put that context onto the player. Yeah, let me do this. Let me set it up so that player has like the default stuff. But then I can change that later. Because an issue that I was running into with Zombie Game was I would create a test world and I put the player in there and I have to set up input every time. Because I wouldn't. Yeah, let me just do that. So this will be a preload for this, and this will be a preload for this. Just throwing that in there is already going to be really helpful. So I'll just have a input group here. I gotta take the dog out. I'll be back. I'm back. I just realized, did I compile yesterday? Did I? I don't know. Today, I don't think I am. I did. Yeah, I definitely did yesterday. Today, I'm not. Definitely not. Okay. Alright, so let's say export subgroup look. Okay, and what I'll say is I just do guide, enable mapping context, and put context look. Move. Okay. Not moving. Is it because player doesn't have these like defaulted or something? They're set there. Are they not set here? Those are set up there. Oh, I have desired velocity, but I don't actually do anything with desired velocity. All right. So if we're not on the floor, we skip that. If we're not on the floor, we say we're on the floor, and then I'm just gonna say, what I should do is I should take my desired direction and I add that to my velocity. Okay. If we're approximately 0, let's apply some ground friction. So I will say what's this? I'll say so after a second our velocity is halved. Let me say after a second our velocity is a tenth instead. This should be pretty small. Otherwise, let's say linear velocity let's make our linear velocity interpolate into I think what I saw Jolt do was it takes its velocity and it interpolates it by 75 and 25%. But then there was something about... There's something to do with... Like, it's definitely in character, right? There was something to do. Okay, it's just not there. Virtual had it. Did I not see it here? So your 0.25 is not there. Not there. Where did I see this? Was it here? Player controls horizontal velocity. Desired velocity is times character speed plus the input movement direction times character speed plus 0.75 of the desired velocity. Control input. Okay. So control input is literally what I'm pressing. So what is desired velocity? What is desired velocity? Desired velocity equals... Ah, okay. That's what I was missing. Desired velocity is equal to the current desired velocity plus 25% of what we want to move in. So, interesting. Definitely is. I don't know if I really like that, though. I think what I'd like to do is I'd like to say... It's going to be slidey at first. Let me just start by saying linear velocity is equal to I have the acceleration, right? Oh, it's deceleration. Should be... If I'm pressing no button, we damp. I guess actually in that case I just use deceleration. So it should be subtract its current velocity times deceleration. Okay. Okay. Jolt vehicle? What? Why is this here? This isn't here. What? What? That's not there. That's not there. Why is Jolt Vehicle here? I'm on planet. I haven't even pushed. Oh, what? Hang on. Okay, I think it's just like documentation. There's documentation for this, even though it doesn't exist. I think that's what's happening. Jolt Vehicle isn't actually here. This must also just be from documentation. I don't think Jolt Vehicles is actually there. It would not make sense if it were true. I think if I try to do it here, it should tell me no. Huh? Yeah, it's not there. Right. It's not there. It's gone. I was like, how is it here? It's not there. But I'm okay, so I am concerned now though. I am concerned because it seems like whatever. I'm gonna ignore it. I'm gonna choose to ignore it. I'm not gonna count this. It doesn't count, okay? This doesn't count. I just have to do this to make sure that it's actually correct. It's possible that I compiled zombie game because I really don't know why Jolt Vehicle is apparently there. It's got to be a documentation thing because the documentation is different from the code. So it's probably the case that no, I clicked add and it added it. How did it add it? That doesn't make any sense. I'm not going to count this. It's up to, yeah, it didn't do anything. Okay. I have no idea why it thinks that Jolt Vehicle exists. It definitely does not exist. And I'm confused as to how I'm even able to do this. I feel like I should be able to do that. But I'm just going to ignore that. I'm not going to think about that. I'm just going to assume that if I were to hit play, it would not know what to do. It would like glitch out or something. Or just default to rigid body and not actually do any kind of vehicle stuff. Okay, anyway. Set that up. So I subtract the deceleration if I'm stopped. And I'm just going to simply do an add. I'm going to add, well, it is desired velocity. I guess I can just do that and ignore acceleration for now. This should at least get me moving, and like it will clamp me to, you know, some meters per second. So I'll say like 4 meters per second. Okay. Now camera. I do want the neck setup, so I will have a node in here. I call this neck. And what I do is I take neck, and neck will tilt up and down. Or neck will handle my rotations, really. So I can spin, well, no, I think what I do is I rotate. I don't want to rotate the body in place. Yeah, because I want to say I don't apply rotational forces to the things when I turn. It's just like the head. So let's add another node, 3D. This will be called head. Camera will attach to that. So I take neck, and neck will be wherever it should be. .28 or something. And the head will be there. Camera will be centered on that. So whenever I look down, the camera will physically move forward. And when I turn, I rotate. I turn the head side to side. Yep. What is it called? There's, okay, let me look up my... I hate using, I actually just hate searching anymore. I cannot do it. Axis of rotation. Alright, so it's pitch and yaw. So this goes up and down, and this goes left and right. Or yaw goes left and right. And in fact, I think I want to put the camera slightly forward too. Okay, cool. So I'm just gonna check these things. Alright, yeah, I have some crazy stuff here. Yeah, I'm just rotating. I'm just rotating my camera pitch by my look axis Y. So these are 90 degrees down. So I guess this is look down max, look up max. Find out what those values actually are. Dig to rad. Yes, that's just a little bit less than half pi and a little bit less than negative half pi. Yeah. I guess I'll define them up here. Okay. So now this should allow me to do that. And then this is not really going to be global basis anymore. It's going to be it's going to be the basis of my camera yaw. So I'll do camera. I guess I could actually just do camera. Let me just do that. So I can use a global basis of my camera for movement there. Jeez. Okay. So I've made a mistake. Not sure what's up with that. Look speed deg to rad 0.5. Okay. It's backwards. So this is actually supposed to be a minus. That's also backwards. Okay, so it is applied in the wrong direction, it seems. Whatever, you know. So this does just mean I need to do it the other way. So camera yaw. I subtract 0.12. And then here, this would be plus 0.12. And then here, 0 that. Okay, so I turn first and then I pitch. Which is a bit strange, actually, if I really think about it. Yeah, okay. That seems fine. Yeah, this is the way that it should go. So just camera yaw, camera pitch, in that order. And camera slightly further forward, slightly forward. Alright, cool. Camera's working. Now I need to have... There does need to be screen locking, so... This is probably the case where I actually do now have a real need for some top-level input control. So I can do I can press escape and detach from the scene, or detach, like, if I'm clicked into the game, I lock the mouse, or a capture mouse, and then if I press escape, I release the mouse until I click again. So I'll look at how I do that. It should just be under script. Not there. It's under scene, world script. Yeah, so I have this pause button up here. So ready, I enable everything and I capture the mouse. Handle pause. How do I recapture when I am back? Try capture mouse. Where's try capture mouse? When do I call try capture mouse? Huh? Oh, on mouse entered. On mouse entered. Okay, so yeah, this is where I should have like, yeah, I should have like some global input thing. So it's going to be a node. It's going to be global. Just close input manager, whatever. And then I have project, globals, there we go. Okay. Okay. And I think this is where I have like a global thing. Call this pause. It'll just be the escape key. Right. And then, yeah, it's just down. Well, let me double check this. I might have set up that this is just pressed. Yeah, I think this is just supposed to be pressed, actually. So it's just pressed. Manager. This isn't really an export. Wow, pause. And then I will also have a fallback where escape is always treated as a pause no matter what. And the reason I want to do that is if someone tries to rebind this button and they forget, they're not like confused about how they're supposed to escape from the game. Escape will just always activate pause. I do want it to be mappable, so I can have 2 buttons. I mean, I guess what I can do in that case is maybe this is meant to be... Like, I don't think these really do anything. I think these are just straight up stuff for me to use. So honestly, let me just have like another... Just the same button twice. It's just there twice. That kind of makes sense to me, because then I can rebind the first one, but then the second one's locked in. Escape will always be there. Right. Okay. Okay, and then I have this stuff, so I do get tree root, and I do all of these, so I'll just straight up copy that. And then these are just at the very bottom. So I'll just copy these as well. And I'll track this. It'll be false by default. Capture requested. Try capture mouse. Retry. Capture requested. I don't think that does anything. I don't think captured requested does anything. It might do something, but I need to see. On mouse entered. If a capture was not requested, we skip. Okay, that's how this works. All right. On focus exited, if we were captured, change that, and then the next time we come in, we should capture. Yeah, I understand. All right, so mouse and window, and then I say, I'm also always passing false, so I'm just going to write this method without that. So I'm going to say is... Yeah, I'll just say capture on enter. Or capture mouse on enter. Maybe I default that to true? No. I'll just say capture mouse, actually. And then I'll say mouse and window, and I'll say var I'll say show cursor. Okay. I'm just going to simplify this. Recapture free the mouse and cue recapture. And I guess I also have like a var. Okay. Let me just say pause on, yeah, I'll just say allow pause on exit, pause. This is going to be capture mouse. And I'll just say if not mouse and window return. And then I say focus entered. I guess I can also say show cursor. So if mouse is not in the window, So yeah, I should say if show cursor or mouse is not in the window, don't do anything. That all drops out. Check that we are not hovering a mouse intercepting GUI element. Yeah, this is not necessarily true, right? Okay. Okay. We're getting there. Then just have pause and unpause. If not show cursor, do that. Okay. I think this is all there. Though I actually don't. Okay, well, I've captured the mouse at least. So there's that. Okay, good, and it didn't recapture after I left, so that's nice. So what I want to say is focus exited. If we were captured, make visible. Okay. And I think what I'd like to do is I'd like to have... Cool. First of all, escape. Oh, yeah, because we're not processing input. That's right. What do I say there? It's called handle pause. If is paused, unpause. So it's just a toggle. Yeah. to there. Okay. Mouse is in there. I press escape again. Doesn't work for some reason. Okay. If not show cursor. Show cursor is false. Interesting. Okay, so it's not taking input anymore. I'm pressing escape and it's not registering that. Oh, it's because this one should be process. Yeah, so process mode equals always. My mistake there. Okay. Sweet. All right. Okay. Right, this is pretty good. I am able to move around. So what I want to do is I want to also set up a third person camera. So I'll call this FP camera instead. And then I'll call this FP camera, y'all. So I guess I want to put this like, I guess just like a meter up. Kind of center body. And then I will have, yeah, just make another node down here. And you know what? I think in a weird way, it might make sense to actually lower this slightly. So that when you pitch down, the camera will actually kind of, or actually should it be up? Yeah, the camera pulls away from the body a little bit, right? And then I'll have a sphere shape cast. And I think what I'll do is I'll just compute these values and then I copy them over to these. So these just take on the exact same value so that the cameras stay consistent. They won't like deviate over time or something, which I'm sure is a possibility if I add them individually. So this will be a sphere. I guess it's fine to be that large. And then margin's fine too. So it should be 0, and then it just should be back. You know what? Let me cast it up a little bit, actually. Let's cast it up a meter. Or 0.8. And then cast it back 2.5, and I'll see what that looks like. All right. And then I guess I will have like a third person thing here or something. Some sort of switch that I can toggle. I think this will just be for debug stuff, so I'll make it like, I don't know, something weird like shift 1 or something. I don't know. It'll be a global thing. Yeah, let's do shift 1. Just when it's pressed. Okay. I need to have some kind of mode here. Then I need all of these. this camera is current, then I do camera third person. What? What? Make it current. So I just match these. And then static world for now. Excludes parent. And then I just say this position is going to be the direction times the safe distance, right? So multiplied by that, and then I do position Z is equal to negative offset. I guess it's just offset. Should just be like that. Just position is equal to offset, right? Okay. So enable the look context. Which this one's actually not really related to that. Yeah, right. So I say if action camera toggle is triggered, then I say I guess I can just say camera third person equals not camera third person. I mean, I guess I can actually say this. It should just default to this one being not current. Third person only. This one's current Doppler tracking. I also have Doppler tracking, whatever, right? Okay, so if I press Shift 1, I should be toggling. Nice. Though it's definitely higher than I would like it to be, so I think what I do is I just kind of manipulate the cast. So make it cast slightly right, move it down a bit. I think I can just modify the target position while it's running. Yeah, this feels too high up. Okay, I think I have to do this. There we go. Oh, it did pause on the exit though, I think. So, yeah. I mean, yeah, I can see it now. Cool, alright. The eyes don't turn, but I don't really care. That wasn't really an important thing to have. And that's just mesh rotation. So, like, I could make it so the mesh matches these. Whoops. No, just node 3D. And then I want to name it. Mesh yaw. And then I would just put these inside of here. And then I can just rotate this by the camera's yaw. Okay. So now my eyes are rotating, facing the right way. So the mesh spins and go third person, first person. I really want to jump at this point. Okay. Let's go further left, I think. Right, I mean. How far do I need to go? 75? Seems better. 90? $1.1. There's also a closeness to it. I feel like this might be too far away. Because I am like literally getting further away as I extend out to the side. Okay. Also, if I look at this and I press forward, does that make sense? Does this make sense? I mean, I think so, right? Maybe that's like an intuition thing. Like after you, wow. Like after you, if you played enough, you like learn how to like move around obstacles. I don't know, this is just debug, by the way. This is not actually, I'm not going to have a third person camera. It's definitely going to be first person, but this is just here so that I can see it. So that I can see what this is doing. Okay. That's good for now. I'm fine with that. I didn't really look at what like up and down really looks like though. I don't care about that. This is not like really a final camera. Okay. That's all there. I only really need one result, which the first result should just be... I actually don't need any results, really. So I can just exclude that, I think. Yeah, I can just exclude that. I think this one also doesn't really use... Yeah, this uses safest. Okay, it does get the normal, so I need at least one collision. I'll just save one. Because I'm only using the first one. I guess I can also do like, no, I was gonna say I can force this. Oh, no, it does take a shape cast. All right, so I actually can do this. I guess I can instead do if. Make it at least one. So I probably don't even need that. I would actually probably just do like alright, honestly, I feel like it must have possibly something like that. So that is a closest thing, but is there... I don't know, whatever. I guess I can just check this at the bottom, and then if not, then I assume the collision is... I don't know. I'll just make it so if it's set to 0, then we set it to 1. And then just be mindful of that. Okay, that's all set up. I think I have not committed this in a long time. It's definitely time, I think, that I do this. And then this, I'm just not going to commit that part. I'm just going to commit the Godot game. Okay, crazy amount of stuff added here. Let me double check my scripts. I don't have anything that I'd rather not send, like this. These are all pretty good. This is working. I might just leave it, honestly. I don't know a better way. to do that because this also includes, doesn't really include max speed, so I think I probably should just set it as like a direction. I gotta fix the camera, and then I change these parameters to decide what that really means. And then acceleration, wow, it didn't explode that time. Then acceleration would be like, I guess I could just not have it be an acceleration and then just say these are your max speed in meters per second, and then the acceleration is more of this parameter. I'm setting this parameter. I guess I could use step. This is, what is it? An exponential. It's an exponential ease, I believe is what this is. Or it's just like a smooth ease or whatever. I think what I'd really like to have is something more tunable, I guess. So I can say, here's your max speed, here's your acceleration. And then, so I can determine, so I can say, all right, after a second, you're at top speed. After 0.8 seconds, you're at top speed, whatever. And then I would like to have strafe stuff. So if I am strafing, I'm actually stopping quicker and reversing direction faster. So I'm applying a deceleration to, I'm using like deceleration as my previous velocity and acceleration as my motion. So yeah, essentially it's like if I'm like over 90 degrees or like over 45 degrees, I start applying a deceleration exactly opposite to the direction I'm moving. And then I apply that acceleration in the direction that I want to move. I don't know. I need to look at it. There's also friction. Oh, actually, friction's handled, really. Yeah. I'll leave this for now, even though it's totally unused. Anything else? Crazy amount of images, or yeah, images, scripts. That's just all guide add-on. Let me just do this first. Commit all of this in one go. So this is a added window trigger, added stick modifier. Go ahead and send that. All right, now it's all just this stuff. Get we're doing all that. Stiffness damping. Handle input, call handle input, desired velocity. I could let this drop lower. I don't know. I mean, that's just like random tuning stuff, I think. Okay, I think this is all good. Um, so camera toggle. Camera toggle. Pausing. Mouse capturing. Yeah, that's it. Okay. Cool. Alright, now I guess what I should do is probably build a full, proper test environment. So stairs, or even moving objects. So rigid bodies that like rotate or something, like very large rigid bodies that are just rotating in place. Let me start with that. I'm actually curious about that one. Let me add a rigid body. This will be rotating floor. I will add a... What? What? That was weird. I don't know how I was adding a... Adding a what? I literally don't know what I was doing. I clicked that? I guess that's what I clicked. And I need to go ahead and get textures in here. These like debug textures, dev textures. I'm really missing that right now. I think I just have it in like textures level. Yeah. So yeah, I think I do scene. No. How can I organize this? This is just like a generic texture. It's not really meant for... I can use it anywhere, right? But I think I did make the mistake of using texture for some other stuff like terrain. You know what? Textures is a fine folder to have, I think. I think that's okay. So I'll make it here so it actually shows up, because I'm pretty sure if I create it outside of Godot, Godot won't find it, and I have to like reload the whole project to get that folder to appear. I'll just call it texture. And then I have dev. Okay, and then here I put all of my grids. All right, cool. My grids are in, and then I need to set the imports. So was it that I want to do this? And then this is like... unimplemented. Funny. Okay. No roughness. Don't do that. I think I just leave it as fastest, right? Set as default. Load default. Load default. I guess let me check this. So if I do that, disable, turn that on, turn that off. Import. This says I've imported with 10 bitmaps and 680 kilobytes. If I do this, or if I do load default, re-import. 1.3 megabytes. It's way worse. Slowest re-import? .3 megabytes. What? Okay. Set as default, re-import. Alright, that one's just better, I guess. Alright. What about lossy? Four megabytes. Okay. Yeah, that's crazy. And just have material. Dev. Standard material 3D. This will be grid black. There's grid black. And then how do I set? Oh, there's sampling. Nearest bitmap. UVs. Let me do turn grid off, turn origin off. Okay. UV triplanar. World the triplanar. It's so blurry. It's just so blurry. Whatever. I think that's it. I just do that. And if I were to move it around, yeah, okay, cool. The grid stays there. If I turn that off, that also. What am I moving? It would be like this? Okay, that moves that. World. Okay, that's correct. Repeat? Interesting. I can't remember which one of these is like better. I'll just stick with that one. It's default. Okay. So now I would just duplicate for each of the colors. Blue. Weird, whatever. Save. Okay. I'm glad they fixed this resource preview thing. It used to be that these would actually just not update ever. They would like use thumbnails from just like literally the wrong color too. Like I would make grid green, copying blue, and I would like put green on it and that would use orange or purple, like one I hadn't even used yet. Some weird stuff was happening. Wait, what? That's purple. Wrong thing. Don't do that. Edit red. It's weird that any of these are a different... I guess it's only blue. Blue has a different size somehow. This doesn't make any sense. Okay, floor. Let's give you a cylinder. Let's make it a rotating cylinder. Is that right? Okay. All right, so it's a step, material. Oh. I think in this case, I actually kind of have to do a custom thing. So I'll load an orange, then scale to UVs. Probably just larger than it needs to be. 4 meters seems good. Okay, cool. And then this, why is it? Whoops. Okay. The whole thing should be lifted. So if I were to rotate, yep, the grid rotates with it. Good. And then I just have a constant, or rather I should do linear lock and then constant force, torque, mass, oh, let's make it 500 kilograms, like a big metal plate on the ground. And then torque, 5 kilograms times a meter. I'll just start with 1,000 and see if that's okay. Oh yeah, it's spinning, and it's not on the correct collision layer. You don't collide with anything. In fact, yeah, you don't collide with anything. You're to be considered static. Actually, I guess it's not to be considered static. No. This just collides with... It's on the static layer, but it will collide with everything. It'll collide with the player. Okay. Weird, I'm standing on it and I'm not moving. Is that accelerating? It shouldn't be accelerating. It should, like, eventually. I think it's accelerating. Alright, let me not do constant force. Let me just do... This is in degrees per second. So I'll say 10. And then hopefully it doesn't damp. It's slowing down, I think. It's definitely slowing down. Collision material. No friction. So I'm not moving now. Oh. I know. I do understand why. Okay, so I want to check if I'm on the floor, I'm on the floor. And then I want to say... I also want to add the linear velocity of my contact point. So push should be this plus get collision. I guess I should get collider. Okay, so I need to do this. In this case, I can actually just take on the velocity of anything that this is touching. I guess actually just the first one. Yeah, so... Get... It's like velocity... There is a way to get that. To compute a velocity at a point on the object. That's what I want to do. Is it a shape 3D? No. What? There's a get... Huh? Do I have to do a ray cast on this point or something? Get local velocity at position. Contact index. Uh-huh. Oh, no, I just do get velocity at local position. So I have to get the physics direct body state of this object. I think I can access that from here. I can say body get state or something. Body get direct state. There we go. Velocity at local position, and then I would just say, hey, Ewo on site. I think the collision point... Yeah, okay. I can just probably just do this. Yeah, I think this makes sense. Oh, get velocity at local position. Hang on. Are you using Arch? By the way, I am using Arch. Velocity at local position. No, I think I just say linear velocity. I'll just keep it simpler. Simple. No, this is a push. This is a push. So push is going to be velocity at local position, I think multiplied by... Yeah, I guess it should just be multiplied by the mass. Um, 1 over. So I just treat it as pushing myself. Shape cast. Get collision point 0. Okay. Let me do this. It's been 0 days without compiling Boneless kernel for me. Funny. 1 day without me compiling Godot. I'm adding VRR support in the kernel. No HDMI forum. I don't actually know what VRR is. Let's see if I launch myself. Ah. That's really interesting. I appear to be moving in the opposite direction. Sure. This is very odd. Oh, I think I actually understand it. So get collision point is in the global coordinate system. Okay, right. So I have to take global coordinate minus translation and rotation. So it's not minus. It should just be this times ground, global transform, inverse. Let's see if body state. Okay. I think that's it. And then it's plus. It's weirdly pushing me out, so it seems like it's still incorrect. Yeah, okay, so it's still incorrect. Do I have to take this times the inverse? Does body state have? Yeah. It should just be inverse. Why is it so weird? I mean, it's really close. This is just not making sense to me. I don't know why this is wrong. Because at the very least, if it's like the plus or minus is different, then I should just be able to walk to the opposite side of the object and I'd be pushed in the other direction, and that's not happening. I'm being pushed in the same direction no matter where I stand on it. So is it not inverse? Am I actually just taking the global transform and multiplying it? No, it's gotta be global transform. It's gotta be the inverse. Let me see this. No. I feel like I remember this being some kind of weird thing where it isn't really in doing this the way that I think it's doing it. So what happens is a global point, I need to get that in local space on the object. So I do, the collision point is in global space. What I would do is I would initially subtract the offset to get an object local space, and then I would apply the basis to that. So that'd be like the inverse global basis. I'll just do that, I guess. So we get this in global position, and then I do I multiply it by the basis. Okay. Also, why is it like always doing that? Yeah, no friction. I don't know. I'll just give it like 100 torque or something. Alright, that's not enough torque. 1000 torque. Oh, this is so strange. I started spinning around it as if I was in the middle, but should these be flipped? Global position minus the collision point? No, I don't think so. That gets it object space, and then I would do the bases. I multiply that point by the bases. Or the inverse bases. So I root it the other way around. But the position was definitely wrong, because I was spinning around a point that was not centered. Oh my gosh. Translate global position into object local position. Godot. Local velocity. What do you mean to local function? That doesn't exist. Affine inverse. What's the difference? What's the difference? So I don't even need that. I can just do inverse. Yeah, it's so stupid. There are helper methods? Really? That actually is a thing? Oh my god. Alright, so this should guarantee work. There's no way this could be wrong. Right? It's pushing me out. It's pushing me around in a really weird way. Like, why am I spinning out like this? If I stand in the middle, I shouldn't really move. Pretty much. But I'm definitely like moving the wrong way, I think. Yeah, this is odd. Is it really supposed to be minus? Like, why is it doing this? This is just such a weird motion. I don't understand. It's such a strange emotion. I mean, it's just totally not correct. It's actually just straight up not correct. I'm really confused by that. It's definitely just not correct. Let me look at get velocity at local position. Why is it wrong? It's quite annoying. Why is it wrong? Hey, you know what? Let me literally print it out. Let me literally print it out. You know, let me normalize it too. Because if I stand here in the quarter, it does this motion. I turn into it and then I start turning out of it. Like, this motion doesn't make any sense. I'm definitely just moving the wrong direction, I think. Like, I'm definitely moving the wrong direction. Let me start with that. Okay, what? I did subtract and I have the exact same motion again? What is going on? What is happening? Like, the weird thing is, that motion is kind of correct if, like, I was standing on a trackball. Like, that's kind of the crazy part. The motion is, like, really similar to what you would see if you were to place a ball on a spinning platform. It would do that weird thing, but that doesn't make sense here. That shouldn't be happening here. I don't know what if the friction is like a weird thing where it's like slidey and that's what's going on. And I'm just like going the wrong way. I'm turning clockwise. So let me subtract it. Let me do the negative. Like, this is crazy. I don't understand why it's doing this. How is that happening? Whether I add or subtract it, it's the same thing. Which is a weird thing. I don't know why it's, I don't know how it's the same thing. Whether I add or subtract. Like, it's straight up the wrong direction, man. Add the force. Why? What? This is so stupid. Is it this? Is it this? Let me, honestly, let me just pass this line. Let me pass that line and see. All right, so let's say let's just multiply it by 0.1. Multiply by 0.1. What is this? Why am I orbiting around that point? As if I'm in the middle of the thing. I'm orbiting around a point. This is so strange. I'm seriously perplexed by this. The thing is, it doesn't matter if I add or subtract the force. The result is the same, which that's crazy to me. I don't get how that's possible. So whether or not I add or subtract the force, I get pushed out. So I'm orbiting like counterclockwise in this location. Or actually clockwise. The thing is turning counterclockwise and I'm orbiting around this fictitious point counterclockwise. So now I subtract that force. And now I'm still orbiting clockwise around some fictitious point, but it looks a little bit, it looks the same. It looks really similar. This is just the craziest thing. It probably should be plus. The minus feels like it might be a little incorrect. Get velocity at local position shapecast to get collision point 0. I think it just doesn't. I think this local thing just actually does not work. It's not considering like rotation or something. Let me see what 2 local does. Let me go find it. Global transform, affine inverse transform, global point. Like, why? Why did my version of that just not work? Second, why does it not push me correctly? Why do I do this orbit thing? Because if I stand on the edge, it starts pushing me out. If I stand a bit closer, it pushes me in and opposite the velocity. What? Like what? I think I might get it. I think I actually then have to transform this velocity back into global space. I think that's actually what I'm missing. I think I actually have to do this. And then this works. Because this is like a local velocity, right? Won't transform it, just basis. Okay, why are you mad about that? What? What? What are you talking about? What, man? Huh? Null context given. Ignoring. Are we serious? What? Why are you doing this? Okay, it just felt like being mean. Oh, now it works. I just have to rotate the vector back on the global axis. And then it's launching me out. Though I do think it's probably meant to be that I probably keep track of this velocity and I try to like I try to match my velocity to the ground velocity, right? So yeah, let's linear velocity times let's do this. So we match our floor velocity pretty quick if we can. So the push will actually be, in fact, actually, let me just set that back. I've got it. No floor velocity needed. What I'm going to do is I take on that velocity, but it's counting as a constant push force. So what I want to say is accept the push force. But I think apply it as my mass? No, it's just yeah, apply it as ground mass. But then I'm standing on this, so yeah, okay, I just track it as like floor velocity. Jeez, stop it. It is so annoying that when I do like a parenthesis, that it instantly... Okay, it doesn't do it here for some reason, but if I do it here... Oh, really? So if I say something, and I write this, what the hell? If I do this... Okay, why is it doing it up here then? Why was it doing it here? Because when I did this, parenthesis, yeah, why? It pops up with acceleration, but the thing is, it's there the whole time. So if I do this and hit enter, I have to hit enter really fast. If I don't hit enter fast enough, it deletes the other word and replaces it with that. That is just so annoying. So what I want to do is I want to do the difference between my velocity and their velocity. So I take yeah, so I take subtract my velocities. In fact, I kind of don't really need to keep that tracked outside, so I can just do that. Alright, but I am applying the difference in our velocities. So in theory I should stick to it, but not really fly off of it. At least I should stick to it better. I did fly off of it. I mean, I guess I can do apply central force. This should update my linear velocity. And then I can try to stick to that. So I could say linear velocity, add the difference of this. Okay, that's better. Now I can't walk onto it. Okay, it's a bit annoying. Why not? Why can't they do that? I'm adding velocity. Why is that not? Why can't I walk on this? I just straight up can't walk on it. I stick to it, that's good. That's what I want to see. I'm also like able to jump for some reason. This is so strange. Okay, let's say what? This is so strange. Apply central force. Oh, state. Jeez. That's the mistake. All right, I forget that I have to do that. Okay, I still can't walk onto it. And I'm on it, and I can't. I also just get flung off it instantly. I want to do the floor's linear velocity and then add my velocity on top of it. Which I don't understand why it's just not working. Because that's what I'm doing. I'm adding it on top. I guess what I can do is I can just do apply central force. and use this multiplied by, I guess divided, just multiplied by my mass. Ground mass. This doesn't stick me to it. Right? Because it's like I'm constantly, I'm not moving with the ground correctly. This doesn't make sense. This doesn't make sense. To add velocity. I'm adding a difference. So I take the floor's velocity and I subtract my current velocity. Is this the wrong way around? Should be my velocity minus that. So if the floor is +1 and I'm +1, I want to add nothing. If the floor is +1 and I'm +1, I don't want to add anything to my velocity. I want to keep going just +1, right? My velocity is +1, the floor is +1. Is that not correct? Do I just add the floor velocity? I guess I just add the floor velocity. Okay, that just like flings me so fast though. Yeah, so linear velocity plus floor velocity minus linear velocity. I want to add it's like x equals y minus x, or x equals x plus y minus x. X equals x plus x minus y. Is that what it's supposed to be? Oh, okay. I launched to infinity. Dude, what is my issue? Maybe I just say, set my velocity to the floor velocity. And then I apply this force afterwards. Maybe I should just have this written up. Maybe that helps. Oh, also, I'm not doing state here. Is that my mistake? I'm accessing these things directly. That might also be my mistake. Okay, let me try writing this down at the bottom. Nope. Add the difference. One second. It's standing time, in fact. Okay. I mean, it's probably this, right? Like, this is just what's kind of going wrong. I should just be adding my desired velocity. That could be what's wrong too. It's just so weird. Why? 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 I don't know why I can't walk onto this. I'm only modifying. I'm always adding. I feel like if I'm walking into it and it's like a big subtraction backwards, I get up onto it, I'm now moving with it. So for like one frame, I'm like moving with the thing, and then I add a velocity into it. Okay. This must just be the only way to really do it. Start with that, and then yeah, I'll just do that. But if I'm 0, I'm trying to stop, which means I actually want to trend towards, I mean 0, I guess. I don't know. Like, that is such a hard thing to do, right? Am I should have interpolation. I don't think interpolation's on, actually. It's also like I'm walking backwards. I mean, I guess in theory I should also match my rotation. So I should rotate with the ground. Yeah, so the ground is applying a torque to me. Though I think it's disorienting. I probably don't want to do that. I think it's probably better to just not have that happen. Oh, man. I'm not going to have moving ground, though, I think. And perhaps just the way to do it is just to have it be an impulse onto myself. So I will just do push. I'll just do that. So this allows me to walk. And it feels okay enough, right? Though I am slipping, I do lose ground going that way. It should be continuously accelerating, so it should get to a point where like I cannot outpace it anymore. Seems like it's getting to that point. Alright, it's even. I can no longer outrun it. And soon I should start coming backwards. I mean, it might also be at its limits. It might not be able to push me backwards anymore. It's not accelerating. Yeah, like that's enough, I think. And I won't rotate the body. I could rotate the body. I could totally rotate the body. But I'm not going to. I think it's good. I should be happy with that. If I run into it, it'll push me. Let me even try that. Let me have like a block that moves back and forth at high velocity, just floating. Like a launching cube or something. It will just move back and forth between two walls or something. Let's say 2. Yeah, it'll be like a metal plate. What? No. There we go. Okay. Why is it centered like that? Why is it doing that? Nine? Okay. Let's do triplanar. Okay, so basically I want this to, I don't know, I guess I will just attach a script to it or something. So my thought is it saves its initial position. Actually, I guess I should just put this on. Basically, I want it to apply a huge force until it reaches a certain limit, and then I teleport it back, I guess. It's kind of what I'll do. Once it passes, once I read that it's beyond a certain limit, then I teleport it back. So I'll just make a node 3D. Just call it launcher. Plate. Yeah. So I grab its child, and then I have my position, so I want to say physics process. The plate will have angle locks and I guess it can freely move. I feel like I almost need two things, really. I think what it should do, alright. It'll remember its current position, accelerate forward to a certain length, distance, and then once it reaches that distance, it stops. It sets its velocity to 0, and then it teleports itself back to that extent. And then it waits a moment and then slowly accelerates backwards until it reaches 0, and then it stops and teleports. And it'll just have this cycle going. Okay. So put this onto plate instead. Yeah, just delete that. Five meters. We'll go at 20 meters per second. And I'll just have some timers. Okay. Rest position and global position. So I say if I guess what I want to say is I want to take its current position and draw a vector to rest position. And if that vector I need it on the forward axis, right? So essentially I take the forward vector in that direction, the distance to rest position, right? How do I do this? Do I have plane? What's a plane? Over or above the plane is considered the side of the plane towards where the normal is pointing. Okay, so I guess I can use plane and then I can say from the normal vector and a point on the plane. Yeah, that works. Oh, wait, what? A, B, and C are... Wait, X, Y, Z. Oh, weird. Okay. Yeah, okay. So I can actually just use a plane constructed from that. So I guess just do this. Because I am just considering the distance from the plane of any point. Yeah, so rest plane is just the forward vector of the object, so global basis Z. Okay. if we're not extending, and yeah, so if we're not extending, if timer is greater than 0, otherwise the timer's up, so I say extending will be true. This is just return actually. Say I'm extending. If I'm not extending, timer's positive. Then I do this. Okay, so then I check. The timer's ended, so then I check where I am. So then I say, if distance to global position is positive, I start coming backwards. I come backwards at 1 meter per second. Otherwise, I'm behind it or close to it, and my timer ended. So my timer ended. I'm ahead of it, so I need to start moving backwards. Now if I reach the end, I need to teleport to that position. Say 0, 1. I'll do that. And then otherwise, I guess I check my linear velocities. So if my I'll do this. If we're not extending too much positive, then I say move back, and I say if I guess here I say else, no. If I am not waiting, which means I was moving, then waiting, it becomes true. I set my can I project the point on the plane? Of a point into a point in the plane. Yeah, okay. It's literally called project too. So project my position onto the plane. Start waiting. Timer equals if weighting and extending equals true. Okay, so I say if timer is greater than 0, so this is like the waiting period after an extension happens. So we wait for 1 second. I mean, I could use like a proper like state machine, but I mean, I guess that's what I'm writing. Return. So then I say global basis dot z, no, yeah, just global position is greater than extension length. Yes, is less than extension length. I'm gonna accelerate. So we accelerate, otherwise otherwise you pass that position, so then I want to say snap to plus global basis z times extension length. So snap to that spot. Linear velocity is now 0. Right? Now, I think what I can do is I don't know how to stop it from. Okay, I'm gonna assume that if these are locked, this is like a local transform. So locally it can move across its own z-axis. Right? That's my assumption. Then I say time equals 1. So we stop, we wait for 1 second. Waiting is actually not true. Getting false timer. So if we were waiting, we stop waiting, and we say we're extending, so then we just come back until we reach that point. Then we say we're waiting, and we stop for 2 seconds. Okay. Let's see if that works. Whoa. Okay. Well, it didn't really work. So extending is false. That's false. I guess I can actually say waiting is true. Waiting is true. Timer ends. Waiting false. Extending true. Extending. I'll take these off. Oh, and I guess I actually do need to have this distance from the origin, don't I? A point on the plane. Yeah. And then it just falls to the floor. That's fine. Collides with those. Looks like it's working. It's gonna push me. Alright. It wasn't very much acceleration. Let me say gravity damping will be disabled. Yeah, just turn that off and do that. Okay. Why does it not wait? I want to make sure this is getting back to the same spot too. So I was touching it there. I mean, pretty cool. If we're positive, set this and return. Otherwise, set waiting to true. Set timer to 2. Teleport. Return. I'm confused. Why does it not wait when it gets back there? Let me see then. Because it gets back there and it instantly starts going forward. Okay, so it's reaches... Oh, we're not setting it to 0. Duh. This is pretty cool. More acceleration. More acceleration and further push. It's cool. Okay. I feel like it's really not pushing me that much though. What's its mass? Its mass is huge. Or let's say 100. Alright, let's go even more than that. Let's go 200. I don't know why I've done this. This is so silly, but you know, just demonstration. All right, let's make it a platform. Let's make it a floor. So if I just do this, move it down like that, so I can walk onto you. Interesting. A little interesting there. A little bit interesting there. Is that a problem? It pushed me off to the side a little bit, which is, you know, kind of whatever. And I'm off the world. Alright, what if I made it, 1 acceleration? Like an elevator. That's still really slow. But I want to see if I fall off of it. It may be an issue with the lateral. I think whenever I do this thing, what I mean to do is just accept in the lateral transformation and not any vertical. Because I think it's this. I think if I take this off, if I just don't do that, it will push me. I will be pushed up. But I shouldn't go sideways. I'm being pushed a little bit to the side there. But, yeah. Okay, so I think what I mean to do then is to subtract any... Subtract any vertical motion, right? So I should remove, I guess what I can do is I can dot with the, yeah, so let me say floor velocity equals floor velocity minus my velocity dot with my up vector. No. Subtract, wait, no, yeah, just subtract floor velocity dot with my up vector. It's parallel to B. Yeah, so it does basis times... No, this has like a really weird thing that it does. Just do floor velocity times the dot of that. So subtracting it. So I don't consider any vertical motion for this push. I mean, I can, but it does seem to be extreme. It's like it's pushing me sideways a bit. Honestly, let me just print floor velocity. Let me just print the floor velocity and see what it tells me when I stand on this. Because when it starts moving up, it should be... I should only see Y. Okay, I see only X. Alright, interesting. So... that's a mistake then. I only saw X velocity there. Why did that happen? This should have just become Y velocity. So this is weird. Alright, what if I don't multiply it like this? I mean, that's a correct push. So why is it wrong then on the spinning platform? The platform is just definitely wrong. Because this gives me the correct velocity. It's gotta just be some multiplication that I'm getting wrong. Why it's wrong? Okay, this is correct. Rotations are not correct. This should be like entirely... So this position is entirely oriented. This should be straight positive Z push from this guy. This should be like very high positive Z. I'm getting a lot of negative X for some reason. It's pushing me away. It's pushing me backwards. So why is that one incorrect? Is it possible I set this up wrong? Could this be set up incorrectly? I don't think so. One sec. Why is this one wrong? It's definitely correct with the floor. The moving platform is 100% correct. So let me just try making this sideways again. Whoops. I'll even rotate it this way so it's pushing me. Oh, no. Yeah, keep it that way. So it's pushing me in this like weird direction relative to the world. Give us now floor actually, so. Okay, let's make a flat moving platform then. Alright, let's make this a launcher. Like that. Call it elevator. Elevator. Just make this larger. Okay. Duplicate. Slider. So this will be oriented like that. Clutter will be adjusted to be like no, yeah, leave it like that. Then I just rotate this. And then I rotate this. So this is the way it will fly. And it just slides back and forth. +1 on the X, that's correct. Yeah, just about stuck to it. I could do a thing where I make these like floors. I mean, honestly, what it should be, if I can just figure out how to make it so this push is equivalent to what will push me. So apply central force does some like, yeah, let me go look at apply central force. Let me go find that. Body apply central force. Cannot write this one. How many times do I have to search it? Body apply central force. Apply central force. How many times this is nested, by the way? This is insane. It's just calling a deeper and deeper function constantly. The same time, the same function. So crazy. It calls body, apply central force. And then we don't get any further than that. Oh, here it is. Controlled body, add force. Force. Seriously. Which one of these could it be? It could be any of them. Could be any of them. Let's try this one. I don't see add force here. Maybe it's in this file. Nope. Oh wait. Yep. I know there's an inline file, but is that true? Oh, maybe it is true. What does add force do? Add force. So it was here in the header file, pushed off to the side so you can't read it. Add force right here. Store float. Load. Store float. Motion properties force. So this must have a thing where it applies all that force, right? M force. It's like apply force. Apply force, torque, and drag internal. So linear velocity plus inverse mass times accumulated force. Delta time times, okay. So what this means is I say step times floor velocity times the inverse mass? My inverse mass? Yeah, times the floor inverse mass, I guess. That's what they do. Okay. Yeah, look at that rotating all around. Like, what is going on, man? Why is that rotating? Why is it rotating? Why is that rotating? Motion is correct. Angular velocity is not correct. Somehow. Also, I'm not even moving anymore, which is weird. I don't know why I'm not moving. Maybe this is wrong. I just do that. All right, just make it a push. Just make it a push. So why does this rotation not work? These are all correct. This should be negative x. Yep. Perfect. Right. The other one does not work. Both translation and rotation. This is what doesn't make sense. So I think what I'm just meant to do is probably do a translation and not account for rotation. So I just translate this back to the center. Okay, it's pretty correct. All right, now are these correct? One on the x. Negative 1 on the x. Yep. It slides out from under me though. I wonder if I take this as I would like this to stick better, which means I need to apply more force. So but ground mass, this doesn't really make sense, right? This should probably just be my mass. What if I divided this by the delta then? What if I do that? I don't know why I thought that was correct. State dot step. Okay. So it's quite a lot. It's quite extreme. Okay. Apply central force is going to apply later, like this. It does this. It does this plus delta times inverse mass times the push. So it's literally linear velocity plus that. So it's really just force times inverse mass times delta is what this is doing. And it's adding to linear velocity. So if I take this out, this could just be considered state, linear velocity, add step times push times inverse mass. So this should be doing the same thing now. Okay, pretty much, right? Pretty much. So now here what I can do is I can say state linear velocity add the difference. So add the change. Well, yeah, I think I take floor velocity minus my velocity. So if we're the same, I don't want to add anything. If floor velocity is higher than mine, I want to add that bit extra that it's higher. Okay, so yeah, it should be floor velocity minus. Which, here's what happens, right? If I write this out, that's what I've just written. So this is incorrect. What this means is I'm say my linear velocity, add floor velocity, subtract my linear velocity. So I just totally negate whatever my linear velocity is, and I just accept the floor velocity as my velocity. So I think what this means then is I actually want to run this at the top before I do any changes. Yeah, this is just stupid. Why is it like this? right? Because simplifying this is just saying these terms cancel out. So I just left with that. That's what I've done. I don't want to do that. I want to take on my on the floor velocity. Add the maybe it's like this. Maybe it's like interpolate towards floor velocity. Like maybe like 50-50. I guess I could, would this work if I said floor velocity, subtract my velocity, and then add, I mean, that's exactly what I've written. Man, why is it so, what am I wrong about? Is it this? Like, I don't know. Maybe this should just be first, the first thing I do. I mean, I can save. Okay, 1 second. 1 second. I think what I'm missing is I should interpolate towards floor velocity. That is what I should do. I interpolate towards floor velocity. When I stand still, I want to interpolate towards this. So interpolate quickly to ground velocity. Otherwise interpolate towards desired velocity. And the first thing I do is I say, I compute this as ground velocity. For the next frame. Ooh, for the next frame. And I don't do any movement here. But I guess I can add the push to it. So just say ground velocity. Funny. Funny. Which is weird because I collided with the floor and it didn't update that. So I don't know why. Oh, I guess I should just say else. Zero. Yeah, that's probably what I meant to say. Sure. Okay, take the push off, I guess. Yeah, see, that's kind of like the problem, right? If not, I want the thing to push me with my, as if I was pushing myself, I guess. So yeah. Actually, I guess in this case, the push would be the difference between our velocities, right? So I just take the ground velocity and apply a push as it's different from my velocity. Yeah, sure, right. So if I stand on it, should just move with it. It shouldn't, though apparently I can't move forward. Yeah, I mean, this is just, like, ridiculous. What's going on? Oh, no. It is the interpolation not being correct. I should just be adding to my velocity until, like, my ground. Okay, so if I think about this like most correctly, what are the forces happening here? The ground will push on you if it moves. That is also a multiplier of its friction value. Really. So let's drop the ground velocity. And I need to say, get rid of these. So this is a damp, right? I want to let me just say this. Technically what happens is I always apply friction, but I also apply acceleration. If I am accelerating relative to my ground, if I'm moving faster than a top speed relative to my ground, I apply a lot of friction. You know, right? And then if I am moving in the desired direction, and I'm moving faster in my desired direction than my top speed, then I do not add any more acceleration. I don't add acceleration. Okay, let me just make this super, super simple. Okay. So this is that mass pushing on me, okay? Now, I'm going to say if... I mean, I guess I can do this. Motion plus that. Well, I guess what I really do is I do step times, I'll say friction plus push plus friction plus forward plus push. Okay. So now from ground, I have a ground. So I compute friction as the difference between the floor velocity and my velocity, right? I guess before I even do that, let me just say, this is going to be an acceleration. So I'll just make this desired velocity. And then now I check if say ground. If I have this, now this becomes my ground velocity. Push will be adding well, this will really be friction, in fact. So there's my ground velocity. And now I'll compute forward is desired velocity. And then I'll just do that. Actually, no, yeah, call this push. Why didn't even get spring break that? I don't know. That off. So if the ground velocity has any vertical component, I think I want to include that as a push. Any lateral components, I consider friction. Right? Um, Going to basis dot y dot vector. So I take a push from here. So if it's pushing up from my shapecast collision, I take that as a push, as a vertical push. And then any lateral motion will be friction then. So then I guess what I will actually do is I just compute ground velocity, subtract state linear velocity. So this is my velocity relative to the ground. So if the ground was 0, 0 minus linear velocity. Wait, is this a linear velocity minus? It's meant to be that. So if I'm moving 1 meter per second forward and my ground is moving 1 meter per second forward, I take 1 minus... Yeah, okay. And this will be my... laterally. So minus the ground velocity, then subtracting this piece. Okay, so then I subtract that vertical component. And I guess what I can really do is orient it. Well, I mean, my global basis y is never going to change. So, whatever, I'm just going to keep it. Okay. It can change, so I'm gonna write it as if it could change, right? Like if I say I'm falling that direction, it'll work out. A vertical push will be that way. And I subtract that vertical push. Okay, so there's my ground velocity. So the forward will be desired velocity. If my forward... Okay, so here's what... So I have friction in the opposite direction of my ground velocity. So my ground velocity is pushing me that way. The difference between my velocity and that is going to be the friction. So it'll be 1, it'll be 0 minus 1. So -1 friction. Is that right? No, friction. It would pull me along. Right? It's as if I'm moving that way relative to the ground. So yeah. Do that multiplication first and then just add these components. I guess I'll just start with forward. So forward, if the difference between my desired velocity and my ground velocity or I guess rather it's the direction. So if there's been my desired velocity and the dot of this, no. No. But I'll just keep it simple. And then friction will be as a subtractor. So it will be ground velocity minus state linear velocity. Times like some value, like 0.5 or something. So well, actually, I've already computed it. So it's actually going to be otherwise, I can compute my ground velocity to be my linear velocity. So this should just be the friction is an opposing the ground velocity. We'll just say negative 0.5. Okay. Why are we bugged instantly? It's doing this stupid thing again where it just breaks for no reason. Okay. Very slidey. Very, very slidey. I really hate that that keeps happening too. That's super annoying. Why is it like this? Whoa. Okay, I'm accelerating forever. Alright. In fact, it's actually going to be this all together plus forward minus friction. Why did I just hard stop it, by the way? Right, I'm stuck onto it. Cool. Move that way. Cool, it looks good. This way, I get fast. Great. If I turn this off, I kind of want to turn this off, actually. I kind of don't want this to collide with anything. Don't collide with... Well, it exists on 5, but don't actually collide with anything, please. Okay, so I'll still move with it. Good. Now that should actually just accelerate forever, too. I can walk forward on the path, walk this way, walk that way. Though it is definitely getting faster, maybe. Hopping over. Right, so there's some friction happening there. This is way better, way better. I can actually move around things. My gosh. When I just follow formula, like, you know, the rules of nature. Okay, although it seems like it's not pushing me up like I kind of expected it to push me up. It seems like it got slowed down quite a bit. So let me just do the same thing again. Let me just say that the elevator and the slider don't collide with me. Yeah, don't collide with anything. And don't collide with anything. I will still collide. Although I think what this means is that if it moves too fast, I will fall through it, though. This should still work normal. When it flings you back. Yeah, I just fall through it. That's what I expected to see. Okay, so I mean, they have to collide back with me, but also, I suppose I just probably make these heavier. So make them like a ton. That should reduce my impact on their acceleration. I'll make that 2 tons. And then this has to be multiplied equivalently. So I do slowly slide out, which is great. That's totally fine. You know, friction is not equal. It would take, you know, actual effort to stay standing on that thing with how fast it's rotating. That's good. I can like jump by looking up because the thing doesn't properly connect to the ground. I just phased through it again, so apparently okay. I messed these things up. I thought I enabled these again. Okay, I only enabled on one of them. I just stopped it. What? Oh, it sleeps when I stop it. And I have to wake it back up by touching it again. Okay, it's just broken. Alright. Guess I just make it slightly thinner so that the collider is not touching that. There we go. And then it breaks. I don't know why it breaks. Oh, there it goes. Apparently it still collides with the floor. Oh, it's got a weird angle thing happening. I see it now. Axis lock, angular. Okay, so yeah, only rotate on that axis. Yeah, because what I did was I pushed it into the ground and then it started colliding with the ground. That's what was going on. If I like stand in the middle, I can kind of hold on, right? I'm getting flung out. Yeah, the middle I should be able to, whoops. I am sliding out already. It is getting really fast. That's also happening. Okay. Push me up. I'm just heavy. Short. All right. That's just about working. Let's make this like actually 0.8 ground velocity instead. So there's a little bit of stop at least. 1.5. Pushing me backwards, pushing me backwards. Whoop. Okay. So this is closer. I think should just send this because now I just have to compute forward and friction a little bit better. What does it look like on this platform? Like, I do slip a little bit, which is fine. And it is constantly accelerating, so any slip that I have, I keep slipping at that rate. So a real elevator would pick up and then stop accelerating, and then friction would keep me in place on it. Okay, cool. This one's weird though. I feel like this one, I mean, I guess it is accelerating at 2. Is it accelerating at 2? Oh, it's accelerating at 1. That's like an acceleration for a normal elevator. It seems like maybe it's not pushing me correctly. I guess I can print out the push and see if I'm getting pushed in the right way or not. Yeah, and then that push limits out because now it's actually having to lift me. I mean, I guess technically I'm also supposed to push against something too, right? So perhaps that's something I try. Maybe I try. It should be apply impulse or apply force. My force is my state linear velocity times my mass. At the apply force is on offset from the body origin in global coordinates. Okay. All right, well now I don't need this. Whoa. Inverse mass. I slowing it down? Nope. Get me up there. Okay. I don't know what that name is. It's all dark. I can't read that. What if I redeem the channel point worth? Nothing happens. Nothing happens. Why am I falling like that? Is it the push? Weird. Was that happening before? Like if I take that off? What is this name? TJD. Okay. Oh, I just launched over it. Okay. Yeah, that was already happening. Okay. Whatever. It does have to be a push though, so this does have to be T.Y. This needs to be a max. So I'm not adding, I'm not subtracting a push, which would be weird. Little weird. I mean, if the floor is moving down, I think the real thing is that the spring should be able to extend slightly down. So maybe that's it. Well, okay. Well, it is constantly No, it is not constantly accelerating down. It's moving down at a constant speed. So why am I bouncing off of it? Maybe that just means my character is pushing too much. So maybe less stiffness. Also, height offset price should just be a positive value instead. Like 0.05 or something. That's 5. We'll do 0.3. That may also help. Slightly lowering that. Because that should allow it to decompress. Whoa, decompress slightly when it goes down without bouncing me. A little bit better. Maybe I could read in and like have some downwards push. What do I need that? Yeah. The ground can only push me, it can't pull me. I don't stick to it like that. But what I could do is I could move down slightly with the ground. I could say my forward takes on some of it. A portion of the downward? Nah. I could say fall. I don't know. No, because it should just be free fall. Free fall. Okay. Make it back to that value and make this 0.5. It's weird. It's weird. It is strange. I could have more damping, maybe? Just trying to think of like what could fix that. I gotta fix that movement thing. I don't want to solve that by a step down, but maybe that is just some sort of step down thing where if I detach from a ground, and I'm moving down, yeah, let's say if I detach from a ground with no vertical then maybe I do an extended sweep or something. Okay, let me set this back. I gotta get food. It's late. Okay. I'm gonna get food. I'll be back. I'm back. I've got food, and I'm going to eat. I'm actually liking this controller quite a lot. There's not been any weird stuff. If I type it in correctly, it just works. It just works. Notice I got a mistake here. Vertical push. Should be multiplied by body state. Or I guess just if I can find the letters, ground. Mass. Right. I'll be back. I'm back. Okay. Jeez. I'll look at this again. It does top out, which is weird. Is it possible for this to be like okay, so I think part of it is that this is also multiplied by inverse mass. So it's like the mass difference, right? So what if I multiplied this by my mass? Or I guess divided by. I mean, this is probably where stuff is gonna get, like, perhaps a little unrealistic, but I just want to see. Because it is the case that if I make the impact force too extreme, yeah, that happens. Yeah, exactly that. Okay. And now I'm gonna be probably stuck in the air. Oh, I'm fine. Yeah, so don't do that. Don't do that. Okay. But it is a push force, and we push opposite of each other. So I push into it, it pushes into me. I bet if I take this off, maybe it's a little bit better for these platforms. That kind of makes them to be infinite mass, essentially. They're not affected by me. I say infinite mass. I just mean, like, I don't want them to start slowing down because they're pushing back on me, but it seems like that does happen. It seems like the velocity of that object does stop increasing because it's hitting me. I mean, I don't know. Should it be times my mass? So just do mass. Then I can actually see it. Whoa. Well, that was interesting. What? Positive. Push. What? Huh? Not calling this does that? What? Oh. I understand. Just whatever. So it's the velocity times not my mass. There should be ground mass. Then I subtract subtract vertical velocity from the ground velocity. Okay. That was strange. As far as I'm aware, this acceleration is possible to withstand. Perhaps what I should do is I should actually take this push and apply my push back onto the ground. And then additionally apply my velocity onto the ground at the same time. So I do this. Like, should probably be body state. Apply force. Why does it not like that? Local position, not force. So I push back in the ground with my pushing force plus my current velocity. And then I'll just multiply that mass. I feel like that's a little silly. I'm not changing mass of my object via state. But I mean, technically, if I do change anything, it does override it. So if I were to change mass, it would actually not take effect here. Because my right to state would then overwrite the mass. So I think perhaps I just make it stiffer and more damp. I should have to increase this so that I can stand with a meter per second pushing me down. And I'm just gonna put myself on top of the elevator. This is just kind of getting annoying. Having to move over here. Ooh, should leave that on. And I actually would like to start in third person, so start in third person. Alright, that just didn't work. It only flips when I toggle it. Alright, so let me say if camera third person does not equal so if this is true, this should also be true. If they're not equal to each other, then I need to figure out which one I need to turn on. Okay. Okay. I think I can actually just... let this run. We were already interesting. Let's move the mouse out. Move the mouse out. Oops. Okay, so I can't move the mouse out without pausing it. Whatever. Remote. Why is this like that? I don't know. It should be able to handle this acceleration, so I don't know why it's like just not handling that acceleration. This is like the slowest acceleration I could apply to the character. So if I want to ever have them move on a real platform, how is it not able to handle that acceleration? I'll increase the damping too. I'm just quite confused. What's the problem? Why does it do this? Because effectively, this is just like I'm adding mass to the body, right? When I start accelerating up, it's as if I just increased gravity. So from like 9.8 to 10.8. So how is it like it's like it's falling behind is what's happening. I think that's what's happening. I think no matter what I set the stiffness to, it's going to fall behind. Yeah, it's falling behind. Okay. All right, let me think about this. So it falls behind. Maybe it's that the push up. Maybe this push is wrong. Maybe this push is wrong. Maybe I shouldn't be doing that push. Maybe that's what's happening. Okay, no, I guess not. It's not that push. I mean, logically, I have pretty much typed in 10.8 for gravity, and my spring just slowly compresses down. Right? That's not correct. So why does that happen? Why is my spring slowly compressing? Because it gets stronger as we press it down. Is it this? Is it the fact that our motion is in the same direction as the spring velocity? So what if I just said damp was 0? Let me just make damp 0. See what happens. It's not accelerating faster, is it? It could, if it's accelerating faster, then that could be the problem. But if it's accelerating at the same rate, it should just be it's accelerating at the same rate. It's not accelerating faster. Up velocity is positive. So let me clamp this to or not clamp, but yeah. Do that. Doesn't make any sense. Also, I think this is meant to be like that. It's meant to be positive. Or only really positive. Oh, wait a second. No, this is linear velocity. This is where okay, so this is a mistake. Up velocity is supposed to be like the motion of the spring, not like its world velocity. So if I'm standing on the ground, my up velocity is actually modified by the ground. The ground pushing on me is the effect on the spring. this is my up velocity relative to the ground. So as I accelerate, even though my velocity relative to the ground is actually down, my up velocity is actually negative into the ground. It's considering my up velocity as being up, as if I'm coming off the ground. So this needs to be in the frame of the actual ground velocity. So I can say, yeah, so I can get vertical velocity here. Push. So before I add to push, oh yeah, my push is supposed to be down. So okay, so I actually have to compute up velocity elsewhere. So I guess I can move this. All right, so push needs to be out here. This calculation though, so my velocity is actually the velocity of the spring is that the spring is compressing or expanding in. Spring direction points in the direction that I push. Also, I was thinking this can probably be turned down a little bit or something. Like 2. What's this? I was gonna say the square root of 2. What is... What is this? Is this algebra? Trig? I'm looking for one of these. 1/2. That is 1/2. Alright, 1/2 it is. Up velocity. Yeah, it's the motion of my body vertically motion of my body relative to the ground velocity in the direction of my spring. So so I grab the ground velocity, and this is where I would compute up velocity. I'm just going to move this down. I'll call this spring velocity. Okay, so once I've computed that, I can compute spring velocity is spring direction dot with vertical velocity. So this is the difference between my vertical velocity and the ground's velocity. So if I'm moving up 1 and the ground's moving up 1, my vertical velocity is 0. So I can subtract that. If my vertical velocity is 0, or I mean the ground's vertical velocity is 0, then that's that. So then damp has to be computed here from spring velocity, and then just copy that. Ground velocity is my linear velocity. And I can just compute this here. No, it should be this velocity minus vertical velocity, like that, other way around. So if I'm moving down 1 and this is moving up 1, this would be -1 minus 1, so that's a total force of 2, -2. So that would be correct. That makes the damp correct. Okay, so now damping is calculated correctly, and then I would say apply force that. And then I additionally say I receive more force from the ground pushing me up as well. Let's get spring velocity in there. Oops, like that. So is all this correct? Maybe it's better. Right, my damping is actually going down. But maybe I should take this off and not do that. No, then it definitely does max out. So then I apply my push plus my mass, and then I push myself by its force. Well, should this actually be spring velocity plus spring velocity instead of vertical velocity? I don't think so. Wait. Okay, so this is probably... Yeah, it's only in the direction, which is not quite correct. This could be... velocity. I mean... let me just print depth, I guess. Yeah, this is only positive. It won't become negative. It's staying 0 there. But this needs to be negative for spring velocity. It needs to not be negative for this calculation. Okay. So I have to take that off. And I guess what I can say is if this... I guess I can dot this, dot vertical velocity with this. Run the same calculation, but use a positive value. So positive vertical velocity and then vertical velocity. And yeah, like I said, accelerating up will be like the exact same thing as making the object heavier, which just means it either goes down and sits a little bit lower or bottoms out. And then it like recovers from there once it bottoms out. Or maybe it won't recover, but it should perceptually look the exact same as if I just increase the mass of the character, which just means the whole spring sits a little bit lower. That's all it should look like. And it's not looking like that. It's constantly compressing. So I think about this in a better place. I take the difference between this vertical velocity and linear velocity, and this is the true spring velocity. But it seems like I may be missing something else still. There's the compression, which is just fine. I'm going to take this off again. I'm also going to take off plus forward minus friction. This should just be maxed. In fact, the friction should just be maxed out. What? Why did it peak? It wasn't peaking before. Does this help it? No, it's bottoming. What? I just made it so it wasn't bottoming out, and now it's bottoming out. Why? It was like not doing it until like right near the end, then it would hit. But I was always... What is going on? I swear I'm being lied to. I swear it. It's lying to me. Okay, so spring velocity hits 0, which just isn't correct. I mean, I guess that actually is correct. But the fact that it can't push up is weird. It's not able to push up anymore. In fact, even when the velocity stays the same, and we're not accelerating, it still can't push itself up. It's so strange. Why not? Why is it happening? Why is it happening? I mean, this should actually just be minus ground velocity. It's like, yeah, it's like negative 0.2. It's like, oh yeah, we're falling negative 0.2. Like, what? Why can't it push up? Spring. Taps out at 86. I'm serious. In an accelerating reference frame, it's just like your mass is increased. That's it. I guess it's actually not quite like that. That's what it perceives as. So if I just double the mass, remote. Because am I not sitting lower? I'm actually really confused. What? What? Explain. Oh, jeez. Oh my gosh. Can't even get on it. It's going too fast. How's it going so fast already? Oh, jeez. What is happening? Something, I feel like I'm doing something wrong. Something is going wrong, I think. I mean, maybe what it is I take... I would update my vertical velocity at this point from the ground pushing me. And then I compute my spring velocity as... Is this just wrong? Because is damp meant to apply? Because I multiply by mass. Why do I multiply this by mass? That doesn't seem right. Because this is a force. This is a spring force, and a damp is reducing that spring force. This multiplied by mass doesn't make sense. Is that the mistake? Uh-huh. Oh, actually, there's kind of another thing here. Turn that on. And then I do gravity myself. Okay. Add gravity. Oh, there should be times delta, by the way. Okay. What is happening? This is so strange. Always adding gravity. Okay. Is this like ever not? Okay. It's always there. All right. Gravity's just a straight acceleration. What can I do? If I stand on this, do I move? Cool. Okay. Now, the spring force gets stronger with the offset. So let me print out the spring force. Okay. Print it up here. Right? Okay. Gets stronger as you compress it. Now, why am I not being moved anymore by this? Why does this not move me? I'm constantly going into the ground. What if I just comment? Whoops. What if I just comment that out? Or is it this one? So why am I not falling here? Is this shape? Is this shape counting as that? No. This should not be. Turn that off. Now why am I not moving? I don't know. Okay, now I'm a bit confused. Is this shape is this shape counting as like collision or something? Is it actually counting? All right, don't do this. Just do nothing. Okay, so I fall straight into the ground. So now this. Is it ground velocity? Add forward minus ground velocity. Ground velocity is... Okay, well... This is supposed to be the horizontal component, so there should be state linear velocity minus... my... Literally, why does that happen? Literally, how does that happen? How does that happen? Okay. Okay. Stop doing that stupid bug. Please. Take this out. Okay, so it's positive. So damping is relative to velocity. Spring is relative to... Dude, this just sucks. This spring is actually like not fully correct, right? It's just not. That really isn't enough to push me off the ground? That's comparable to the spring force that... What is happening? What is happening? This isn't making any sense. Am I not? Wait. Am I not pushing? No, I am. So what's... Is it because I really did that? Is that really that? That's the problem. And the spring just starts infinitely pushing me up. Like... What, man? Why does it do that? Why can I not write code like that? Okay. Damping to 20. It's definitely like this spring code just isn't right. It's definitely what it is. Like this isn't a correct spring or something. Because yeah, you just end up with like an infinite motion machine. If your damping isn't high enough. Why? What's wrong with this spring? I could just run Godot in there and see. How to code a spring. Let's simulation. In Python, all right.
System in Python with and without friction. Then we'll create some animated plots and discover what this spiral has to do with the spring. I'm Logan, and I hope you learned something new. Let's begin by drawing a spring and a mass. We define x as the displacement of the spring, with positive x towards the ground and negative x towards the ceiling. The spring has a stiffness k and the mass is m. The kinetic energy of the system is simply 1/2 m x dot squared. The potential energy has two components, one for the mass and one for the spring. As x increases, the potential energy of the mass decreases, which is why we have V equals negative mgx. The potential energy of the spring is given by Hooke's law, with V equals 1/2 kx squared.
This is very quiet, by the way. I can't make it louder.
Plug T and V into the Lagrangian and simplify. Our system only has one coordinate.
It's getting quieter.
So we create some animated plots and
It starts out loud, it just gets quieter. Why is it getting quieter?
the potential energy of the mass decreases.
It's getting so, it just gets so quiet.
mgx. The potential energy of
Like he has a fade out happening for some reason.
with V equals 1/2 kx squared. Now we plug T and V into the Lagrangian and simplify. Our system only has one coordinate, and that's just x, so we have one Euler Lagrangian.
Alright, let's just get to the Python.
Let's get started by importing SymPy and then enabling LaTeX output. Now we'll define some symbols. We have m, g, k, t, and x. And x is a function of time, so we need to use our dynamic symbols. Let's define x dot and x double dot. Now we can plug into t, v, and l to get our Lagrangian. Remember that t is our kinetic energy, v is our potential energy. And then finally we can solve the Euler Lagrange equation. So here, we'll write down the Euler Lagrange equation, and then use the solve command, pull out the first.
Okay, can we do like a real simulation, please?
System with NumPy and SciPy. For step 1, we'll define our constants g, k, m, and the initial conditions x naught and x dot naught. X naught is the initial position of the mass, and x dot naught is the initial velocity. For step 2, we'll write down the system ODE. In SciPy, y is the state vector, so y0 is x and y1 is x dot. We return x dot comma x double dot. For step 3, we'll simulate a system. We'll use the solve initial value problem function from SciPy. We'll enter the ODE function, the time limits, initial conditions, and a list of time values to evaluate x and x dot. Finally, we'll pull out x, x dot, and t from a simulation. Now let's generate some plots of x and x
Here,
dots
I'm
so
just-
that our simulation will give us results that
It's getting quieter. I can't hear anything now.
Then we'll plot x and x
Dude.
as functions of time. We'll set the line width, the color, and also give a label for our legend. We'll add a title,
It's like almost
legend,
silent.
X label, y label, and a grid. Running that, we can
There's just no sound.
does not image this graph. For file axis. We spring with friction. Linear damage. The distance
Oh
we get
my
relation
God.
code by first adding our with friction. X dot, comma, g.
The thing is, this is just. Can we get real? Can we get real? Can we do a real thing? Like, we're moving it? Because this, like, pure math stuff is straight up useless. Honestly, it's useless. Oh my god.
Hello and welcome to a coding challenge about springs. This is
30
the
minutes.
example that I make in this code. Value first. I'll begin with just this really basic sketch. Just one variable, just y itself. So y being 200. So we'll say, I got it. We'll say that y position 200, the spring will assume is attached to the top. And then the
Wait a second. Maybe I should look at what.
spring as if I were to pull it down and release, it would spring back up. If I were to contract it and push it in, it would spring back out. That contraction or that extension is the displacement or the extension.
Okay.
So let's say I were to pull it down. Value first. I'll begin with just this really basic sketch. Just one variable, just y100, the spring 200, y as a variable. So in this case, the displacement is 0. The spring shouldn't move, which is what I see. But what happens if the displacement is not 0? Like if I make it 250. So clearly it should spring back up. So I need to calculate that force that I've got over there. And I can make up a spring constant. Let's just use the value 1 for lack of anything else right now. So what do I do with that force? How does that force change the y position? Well, this goes back to the sort of core foundational principles of my Nature of Code series. An object has a position, the velocity changes the position, the acceleration changes the velocity. I cover that extensively. I'll link to those videos here. Other thing that's really critical about that series is Newton's second law. Force equals mass times acceleration. And if I were to simplify that law and just say, well, forget about the mass, it's equal to 1 for everything in our world, force equals acceleration or acceleration equals force. So if I were to say the velocity changes by the force, which is the same as acceleration, and the position, which is y in this case, changes by the velocity, that's all I need. Change y by velocity, change velocity by force. The only thing is I need a velocity variable, and I need it to start at 0. Oh boy, okay, interesting. I'm getting something. It's springy for sure, but I think the issue here is my value of k.
Springy for sure, yeah.
Too high. So let's use a lower value. And we can see there it is, springing back and forth. Look at that spring. Oh, it's so springy. So let me add a little damping in here and just say,
So it's this constant, like, well, what is wrong? Yeah, what? Okay, so max length is the rest length. Yes. That's the rest length. So let me just say she not. That's max. Yeah. It's max length. So this should be so this is how long the spring actually is. Okay. I mean, honestly, why don't I just make it mass? Mass times spring stiffness times offset. Then I could just say something like 2. So if I change the mass, it doesn't modify the spring. So that would be good. What does this do? It's not enough force to push me off the ground. So let's go for 5. Let's go for 10. Let's go for 100. Yeah, start jumping into the air. Like, ow. Is it really that I just should have, like, additional iterations in here? Should I really do that? Because now the spring is too strong, right? Like that's what this really means. The spring is just too strong. Went from 10 to 100 and then now I'm like 20. Okay. 20, I'll start going up because apparently I'm really far away. Okay, not enough. 30. 40. All right.
Say velocity times equals 0.99, meaning it's going to lose 1% of its velocity every time, every frame. And that's kind of like how you might imagine maybe there's some air resistance or some other kind of force that slows the spring down over time. And eventually it comes back to at rest. All right, so you could pause this video now and maybe try some interesting things. Have more than one spring. Could you kind of move it up and down with the mouse? Could you have it go left and right? But really, there's not a lot that I can do with this without adding in the idea of a vector. So let me read.
Okay. So spring force should only be a push. So spring velocity is the body relative to the spring. It's the mass relative to the spring. I guess I could compute this. I could say changes in velocity to the mass is velocity. Yeah, I could just say the acceleration of the body is the spring velocity. Or I guess it is just the spring velocity is the relative velocity to the ground. It's vertical velocity to the ground. And this damping could be thought of as I mean, I guess it is just that, right? Let's start at 1. should eventually settle. It cannot lift me. I'm pushing it. Oh, wow. Okay. We have to do that. Whoa. No. So these are supposed to be... What? Oh, really? No, axis lock to Z. Z points up. Why do they do this? Whatever. And I'll lock this one to the X. It is slowly lifting me. Okay. Yeah, it still sucks. It's just not the same thing. It doesn't, I don't understand why it's not the same thing. Because the difference is that I just made the mass, I made my mass heavier. But clearly, so why is it, what are the values here? 40 and 2. Another default. 50. What is it? Why? It should look the exact same. Is there a jitter happening? Is it possible that there's some kind of jitter where these things aren't quite updating correctly? like an order thing where my ground velocity should actually be like, it's definitely, there's just a wrong thing happening. Definitely something wrong is happening where this should like shoot me up and it's okay. We're just gonna, oh look, it updated. Serious. It's not. You're lying to me. You're lying to me about the values of these things. Okay, good. Why does it crush? Why is it crushing it? Why is it crushing it? I seriously don't get it. Is it literally like a sorting order thing? If I put the player down here at the bottom, does that work? Because of how physics are interpolated? No, it still just crushes it. How? It just falls. It just crushes immediately. Do I have to apply gravity first? I am, right? Yeah, I'm applying gravity first. Should this be applied last? Okay, well, in this case, I definitely have to run it right there. But otherwise, should it be last? Why does it keep going back? Okay, close that. This is getting annoying. I keep like changing it here, and then I'm like suddenly back on test world. Okay. Like it was instantly different, by the way. That was instantly different. I was like walking into it and I wasn't bouncing off of it. Why? I'm not bouncing off of it. Why? Why? So, what's the difference here? Spring velocity is calculated a little bit differently. It was instantly different. Is it this calculation? Inner velocity. Okay. This term minus that term. Yeah, it's this term minus that. Okay, you know what? Let me just start with ground velocity being this value, perhaps. Yeah, let me just start with it being this value. Seems simple. So then here I say body contact velocity. This is supposed to be these values. Comment that out because that's getting annoying. Can't see the code because all this such long stuff here. And here spring velocity is linear velocity minus the body contact velocity. And then I just do ground velocity minus equals ground minus vertical velocity. Body contact velocity minus its vertical velocity. Okay. That was the mistake, right? Oh my gosh, I figured it out. And now I go down correctly. Oh my god. It just works when I type in the formula, when I type it in correctly, you know? That's... It's crazy the difference, by the way. I'm noticing this. I'm doing this a lot. When it's a mistake in my logic, I'm so excited to find it and fix it. But when it's something that's really not my fault that I'm doing correctly, and then I discover, oh, I know I did this correctly, but some implementation is making it wrong. Oh my gosh. The difference is crazy. I really... I'm just glad it's me doing something wrong, and then I fix it, and not there's some bug, there's some flaw in the system that I cannot overcome, and I like discover that flaw. Okay. Spring stiffness. Let's go to 50. Okay. Let's go to 80. I want to see it kind of 200. Okay, 200 too much. $150 too much. Jay, I don't think it even saved it somehow. Alright, 150 is okay. $175 is somehow fine. Like 187 now. Uh, 195. There's a point where this is too much. Is it really 200? Like 199 will be okay. But then 200 starts bouncing out of control. Interesting. Okay. So 200 times the mass. It's too much. What if I make this 10 really quick? Okay, that damping works. It's like 2 times. I mean, yeah, what if I did treat this like it was frequency? That's just a very small by like 2. What? Okay, it's not enough. Let me just not do that. Let me just leave it like this. But it does seem to be like 200 times the mass. But this is correlated to mass. Alright, let me just do 100. So I can type like 1.5. The damping is really, really high. Should just be like times. Okay, so now I'm just going back to times 10. Like 0.7. What? I didn't save that. Oh. Okay, 7's just... Okay, so I need more. Make more. Even more than that. Alright, lift me correctly. There's a big deceleration though, so that's why it launches off so hard. Is this extreme? This is pretty extreme. Okay. That is so fast. Oh. 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 Yeah, they could go slightly higher than that. Oh, and I missed it. Okay. I can't believe it. And then it goes down correctly, like... Wow. Alright, push back. Push back with the push plus my velocity times mass. And it's very smooth. Don't push up now, because that doesn't make sense. I've got it all correct. Positive vertical velocity is not used. Vertical velocity is for that. Spring velocity is spring direction dot the linear velocity minus the contact velocity. Damp. Okay. What about 1.2? It's crazy. It's crazy. It's crazy. It's crazy when it works. Alright, let me turn off debug. I want to see this debug stuff. It should just look smooth. I still have to fix the fact that it's really if I look down, it if I look down and move, I go into the ground instead of forward. I do have to fix that. Alright, this thing I need to like apply some damping to it or something. I almost lost it. I was so close to losing it with this stuff. I was so close. Yeah, so you need some damping on your angular velocity. To limit its max speed. Oh my gosh. Okay, 0.2 is not enough. Let's go to 0.5. 0.6. I don't know why the damp is scaled like this. Because 1 means it loses all of its angular velocity instantly. Okay, also it seems like I'm accelerating it when I get on. Not really sure what that's about. I do apply a force to it. I guess this force should actually be my ground velocity, shouldn't it? Yeah, let me actually do... ground velocity. So that... yeah, because it's definitely the case that when I stand on it, I start accelerating it. But I shouldn't be doing that. Yeah, see, now it's a bit more normal. It's accelerating on its own, but I'm not... me standing here isn't causing it to fly off. If I start doing this, starts going the other way, which kind of doesn't make sense. I think it should actually be going opposing me. So if I'm moving on something, I'm actually applying the opposite force of my velocity. So it should be the push force that I'm pushing up. Oh yeah, it should just be actually the straight negative of all this. I'm applying the opposite force to these. My mistake. Because if you were to stand on a spinning disc and run, you would make it run in the opposite direction of its rotation. So if I run straight ahead, I'm actually going to speed up the disc. But if I run with it, then I'm going to slow down the disc. Because I'm pushing backwards. See? Now I flipped the direction. If I run this way, it will accelerate faster. Because I'm adding my speed to it. Yeah, because then if I run off, you know, I'm pushing backwards on it, right? Okay. And we're not accelerating forever when I stand on it too. Oh wow, this is like perfect equilibrium. It's not getting faster. And I'm pretty much not moving. Okay, I'm starting to move a little bit. Awesome. Okay, proper physics now. Because I think before it was, yeah, it was applying the same push. Cool. Screen. All right. There we go. That's how it should be written. Interpolated camera 3D triggered from outside physics process. Huh? Interpolated camera 3D triggered from outside physics process? It's happening every 15 seconds exactly? What? Physics interpolation. Interpolated camera triggered from outside physics process. Third person camera, then first person camera. Triggered. What do you mean triggered? What do you mean triggered? What does that mean? But players should be turned on for sure. So is it just going to keep saying that every like 15 seconds? Yes, doing it every 15 seconds is going to. What does that mean? Interpolated triggered from outside physics process. Triggered from outside physics process. Cool. I need to make like a new session for this. Is it that zombie game to planet game? And then plus X. Planet game. Planet game. Opens Godot. Alright, cool. triggered from outside physics process. Find it all. Mesh storage. Notification transform changed. Is physics interpolated and enabled? Interpolated camera triggered from outside. Is it the same exact error? Yes. Transform changed and not in the physics frame. Okay. So I'd like to turn that off. Can I do that? I'd like to turn that off then. Because otherwise the input is wrong. Maybe it doesn't get notified about a transform change if I just have a camera. No, it needs to do this. This needs to... Alright, I think... The thing is, I do actually have to update the transform via from process, because otherwise there's lag. You're going to see the lag from the camera. It's not going to move immediately when you move the mouse. So that's going to suck. But it's weird. Request camera update. Does it cause anything strange to happen if I am... Well, goodbye. Does it cause anything strange to happen if I'm in first person and I move? Like turn around? Seems fine. Like, I'm assuming that doing this, right? Because this, I mean, I need it, right? I do need that. I need to change it in non-process. So, all right, let me go look at documentation then and see what notification transform changed is. Global transform changes. Okay. Huh. You know, let me just look that up. Because the alternative is, what are you supposed to do? What are you supposed to do if you can't do that? If a parent of it changes, then it changes as well. Yeah, transform. That causes a, that makes the notification. This guy literally doesn't know what they're talking about, by the way. This famous problem. You literally have never done anything. What are you talking about? You literally don't. This happens, dude. This happens. Famous. What do you mean famous? I don't know what you're talking about. I'm smarter than you, but if I don't know, then it's not real. If I do that, I mean, I can build up input from process. I could try this. I could just see what happens, I guess. I can build up input from process and then apply it all at once in physics process. One sec. Literally, if it's so famous and I don't know about it, then whoa. It's not famous if I don't know about it. Anyone who attaches the camera to a physics object immediately sees like crazy jitter instantly. And that's a common use case of the camera, to put it onto a physics object. Right? What are, what is it? Twitch marbles or something? Whatever that thing is. Those are cameras attached to physics objects. The camera has to be interpolated. Why do I... Okay. Why did I not get this from Zombie Game, actually? What's the difference here? Because I'm pretty sure I rotate the camera based on... in process. And player is interpolated. Pretty sure I do it in process, and I'm pretty sure I interpolate it. So why was this one not having a warning up here? Update first person. Update first person camera. Bam. This changes, this changes. So maybe it's the case that when I finally figured out this interpolation thing existed, because I did cut quite a bit of code, and then shortly after I kind of stopped running the game, it's possible that I just never noticed this. Or it was happening and I just ignore it. So honestly, can I actually ignore that? Is that a possibility? Can I say like, hey, if you match this error, ignore it? Can I say that? So it's not printing. Okay. Oh wait, does open source actually work? Oh wow, it does. Look at that. Like, I'm assuming there's just a discontinuity that will happen if I'm moving the camera while it's being moved physically. Let me see what is physics. Okay. Possibly benign. I feel like it might not be, though. Okay, well, I'm just going to deal with that warning forever, I guess, because I don't know how to fix that. I need to move the camera in process. I 100% have to do that. Otherwise, this motion is not smooth. Okay. Let me get stable move in there. Actually, let me get... Okay. Spring. Big thing happened here. Spring and... Spring and stuff. Let me make this 1.2. These seem like good defaults. Well, maybe they're not good defaults. Maybe I should have a higher damp. Because it does seem like whenever I go over this... I mean, there's also like a stable thing happening here. I don't know. 1.3. Whatever, honestly, whatever. I can make it better later. I can get these numbers to be better later. Well, I do think the numbers were actually different. There. Yeah, because it did used to be 2.4 and 2.7, which is kind of... Did I say 2.4 and 2.7? Oh, really? What if I do this? 2.7. Let me just go for 1.5 and 1.2. This number seems good enough to me. It's enough to lift it. Oh man, the physics. The physics. At gravity. I moved around spring and stuff. Starting in third person. Let me say not starting in third person. That new line should stay there. I'm not sure why I get rid of that. This one should be there. Should not be there. Okay. Cool. Okay. So this is work on character controller physics. Added some moving elements to test world. This would be, I guess I can also say, also added dev textures. Extrude test world. Add ground interaction. Physics. Start on basic movement and friction response. And that's it. Okay. That's been sent. I can drop this. Go away. Stable move. Movement along angle, redirect movement along angle of floor. Okay. Walk, ground speed. Let me get like a sideways moving thing. So I could probably just put this here and have this like oriented like that. And this will restrict along that axis. Cool. Nice. Oh, don't do that. Make unique. Okay. Right. So we go 10 meters, and we'll accelerate at 50 meters per second. That is a pushing thing. Just to help it along. Oh. Interesting. Okay. It's probably the friction thing. Yeah, it's probably the friction thing, which is this will be tested. So that should work. Yeah, this auto exposure thing, not like remembering itself when it resizes, is just super annoying. Yeah, because friction is really it's a partial application of the ground friction. But in addition to that, there's kind of 2 points at which friction becomes there's things that happen. Of course. There's a certain amount of friction that is static, so friction is full ground velocity. So if I'm moving slow enough on like the platform, on moving platform, I fully stick to it. I don't slide off. But then there's a thing once ground velocity is high enough, friction starts slipping. You lose connection to the ground. I mean, kind of like that. So, I mean, I guess I could start by making it like 0.8 or saying, ground velocity times the maximum between ground velocity length and one. Whoa. Okay. Min ground velocity. Yeah. So this should be able to push me now. Or not. Okay. I've been going for 9 hours. Oh wow. Hey Deadline. Want to say hi? Was that all day? I hope you missed me. Bye. I did. I totally did. I have elevators and things. Why are they moving like this? Okay, I just pushed it down really hard apparently. I think something's going on with this. Push it down really hard there. Yeah, what? Tell me everything tomorrow. This thing is... Whoa, what the hell was that? Is that really... Oh my gosh. Alright, I can like really launch myself apparently. Is it like... Can I like push into it? Oh wow, I can. I can just shove it into the ground. Okay, that's funny. That's why it went into the ground so dramatically, because I did that. I think I gotta stop. I think I gotta stop. This is okay. This is great so far, honestly. I actually totally forgot what I was even trying to do. I was trying to do this. There's a movement here. Update first person. Update first person. This doesn't even do that, actually. That's in character base. Does the movement thing. Stable move. So I take up direction, cross with the movement direction to get this vector. And then I cross that with a ground direction to get the true forward direction. And then I just do a dot to slow myself down if I'm going up slopes or not. I mean, that's actually it. That's actually not so hard to add. So this needs to be a switch. So I need to say var what would I call this? Enable maybe force ground movement. Force the controller to project desired velocity onto the ground in the air. Remove any vertical Now, if I'm in the air, I guess I'll say removing a vertical component and reproject to lateral movement. So let's do that. Force ground movement. Okay. So I forward and then I say if force ground movement, then I'm doing this math. Up direction, cross, movement direction, cross, ground, normal, which should be pointing up. And then I cross that. Okay. I mean, it is just that simple. All right. Forward equals cross with movement direction Okay. Normal. Normalized multiplied by desired speed. Okay. Okay, so it's stable. And I just launched up into the air. Why did that happen? I think it's because it's trying to push me up the slope. So this is where I need that slope slow multiplier. So I just dot my up with the ground normal, and that's a multiplier onto my desired speed. So I don't launch when I do this. Okay, I do launch when I do that. Why? What the hell? It's so crazy. Alright, so why is it doing that? Yeah, my 4 just becomes a huge vertical component. Why? Wait, what? Hang on. slope slow. What? Should become like nearly zero very quickly. Should be very small, at least. Point 6 results in that. This is just like a huge upward motion. That's nuts. Do I square this? And maybe that helps? Cube it? No. This having any value at all is kind of bad. All right. Let's say the vertical component also let's say my vertical is multiplied by my inverse mass. Or no. It need to be something like applying to gravity. So, I mean, gravity already pulls me down. Right, this is already pulling me down. It is, I guess it is just forward. I guess it isn't really an acceleration, right? This isn't exactly an acceleration. All right, I'll just call it good for now. It's fine on the ground. I just don't walk on anything because then you launch. Oh, jeez. Does this just not have enough mass? It definitely does. I'm gonna leave it there. I'm not gonna send that, but you know, that's there. I now cannot launch myself into the air by looking up and pressing up. Alright. That's it for today. Thanks for watching. Tomorrow is... yeah, just continuing with this. I need to make it actually properly accelerate. I technically have all these requirements. I also need to have... jumping, crouching, walking, and then this is probably the first thing I'll do is I'll just make it so that I use acceleration instead of adding to my velocity. Because right now, what am I? I'm like adding 4 meters per second every single tick. And I'm just kind of relying on ground friction fully stopping me. Because, yeah, I mean, what will happen is when you move, you're frictionless. You're essentially just pushing through air. That's what's pushing. That's what's like kind of limits your ability to run faster is air drag, air friction. And you're making use of like static friction to push off the ground, right? So I need to get those in there. Those need to be properly modeled. Yeah. All right, well, thanks for watching. I'll be back tomorrow. Goodbye.